Hello Gudia, today we are going to study class 9 science chapter number 7, which is physics first chapter motion. Oh guys, when in school madam taught this chapter or Sarji taught this chapter, you understood nothing. Bro, what is speed, displacement, meter per second, acceleration, didn't understand anything. But beta, I guarantee you, today we will get full physics feel, okay? This speed, velocity, acceleration, all these will be on your fingertips. No, you know nothing. Don't take tension. Sir, we know nothing, we can't understand. Bro, physics wala is here to teach you physics. Just trust this much. By the end of this lecture, you will yourself become a teacher, and in school you will go and start teaching your friends also. In the lecture, you have to focus. You will understand everything. Listen one more thing, this physics wala platform, if you don't know this, it has PW mobile app also, where so many affordable courses are available, like class 9th is there, batches are running. So you can watch that also and study from here also. Okay, you will get this lecture notes, link is given below, just click it, you will get the notes. Now let's start the chapter, but before that, one important thing beta. Today in life, where you are, it doesn't matter. But after 10 years, where you will reach, this matters the most. Maybe beta, today is the lack of money in your house, there is shortage of money, father is doing hard work, you are struggling too much. Maybe beta, you are not that good in studies, but you want to do something in life, and maybe you feel like you can't do anything. That's why I brought this example, which is on the board here. This is me in 2015, and this is also me in 2024. So success needs sacrifice. So set this in your mind, write it in comments, write it on the wall. Success needs sacrifice. Let's start the lecture, bro. So first thing is what we will study today. We will study what is distance and displacement, what is speed and velocity, uniform and non-uniform motion, acceleration, graphs of motion, equation of motion, and uniform circular motion. All these things we will cover today. Don't take tension, you will become a master today. One master is teaching you, and another master you will become after this lecture. So let's start with very basic things. What is motion? What is rest? Beta, motion means the position of an object changes with time. The position of an object keeps changing with time. For example, this is bird. Just now I saw it flying above my head, and a little later I saw it flying further ahead. Its position changed with time. Another example, fish is queen of water. Fish, what about fish beta? I saw it here in the water. Then after some time I saw it somewhere else and it went away. What is this beta? This is the car. The car you want to buy one day. Surely you will buy a car with your own money, and even your parents will ride on it. Of course, it will take hard work and bit of sacrifice. Now what is car doing? It is moving. Its position with time is changing. A little while ago, where was the car? It was outside your house. A little later, where did the car go? Outside their house, home, you have to pick up. Right. Hey, focus again. Now, but a second thing is rest. What is rest? Sir, we know that we lie down on the bed and sleep peacefully. That's the rest. Beta, in physics, rest means when an object does not change with time. Rest. Correct. Simple. Now, this is Babita. I will tell you about Babita later on. We have a long history together. Look, Babita is sitting right here on the chair. She is not moving, not checking, not doing anything. So what does that mean? She's at rest. Her position is time with not changing. Here, this is you. Shanti beta. Yes, what is Shanti doing? He's standing. His position is then changing with time. So what is that? Rest. So motion means position changes with time. Rest means position does not changes with time. Crystal clear? Now you tell me right now, as you are sitting there watching this video on your mobile, are you at rest or in motion? Tell me. Some of you are sitting on the chair with mobile in front. Some of you are even lying down on the bed like this, watching. You can't learn this way. You have to study and take notes. You have to study beta. So beta, what are you right now? Lying on bed, sitting on chair. What does that mean? You are at rest. Right? Right? Wrong. Why? Let's understand the story. I bought a new thing. Alakh sir concept. Ask a different kind of concept. Let's understand in a game. You are at rest and also not on rest. What is this, sir? Okay. Let's say this is our bus of PW. Yes, brother, PW. School and bus, everything is done. Now it's PW's bus. Inside the bus, who is sitting? Babita. Now you are standing outside the bus. Chante, look, Babita is leaving. Now you are seeing Babita living in the bus. Babita is an educated girl. You know about yourself. You go out and playing with marbles. So you see Babita is going and going and going and zoom. I asked Shanti, Shanti, hey Shanti, is Babita at rest or in motion? You said Babita sat on the bus and left. So according to Shanti, what's the state of Babita? It's in motion. Babita is at rest or in motion? We asked Shanti. Shanti said, sir, Babita is in motion, sir. She's gone in bus. There's another man on the bus. Dear Goli. Goli, beta, don't mess around. And I asked Goli. Goli, you are lucky that you are roaming around with Babita. Tell me, is Babita on rest or in motion? Goli said, we are on the bus. Babita is sitting in the back. She is not moving. The bus windows are closed. She can't see outside. It's black windows, full pitch dark. He said, Babita is sitting in the back. She's not moving at all. Babita is on rest. When I asked Goli, Goli said, who is Babita on? She's on rest. And you, Shanti, you are saying that Babita left in motion. What I mean to say is rest and motion are relative terms. It's relative term. It depends on where you are. Who is watching the motion? If I ask that Babita is in rest or motion, Goli will say Babita is sitting. She is on rest. I asked Shanti, you tell me. He said that she is left in motion. Oh. But sir, if I am sitting, then I am at rest, sir. Why you are saying? I am watching on mobile. So I am on rest, sir. And I did not even sit in any bus. This is what came in your mind. Sir, I am watching the lecture on mobile. I did not sit in any bus. I am on rest, sir. I am sitting. Are you on rest? My lovely good, yeah. Come, I will show you the universe. You will get the feel of physics. I'll show you the universe. This is your earth, Mother Earth. This is you on Mother Earth. Shanti, Shanti, this is you. You think you are on rest, but you are on earth, right? Huh? Are you on Jupiter or something? We are sitting on that only, sir. No, sir. Earth is round. Earth is round. You are sitting on earth and you think you are on rest. What are you talking about? Let's do one thing. Let's send Goli to the sun. Let's set him on fire because he was roaming with Babita. He was roaming. He's doing a lot of bus travel. I send the Goli where? On the sun. Here is Goli, beta. If Goli sees you, hoi, you are moving so fast. I asked Goli, Goli is sitting on the sun. Sir, please don't know this. Why you are roaming with Babita? My Babita. I mean Shanti Babita. Now Goli is watching. Shanti is running. Here Shanti is moving very quickly. Shanti is in very fast motion. What kind of motion is this? Brother, Shanti is moving at 30,000 meter per second speed. 30,000 meter per second speed. 30 kilometer in 1 second. From your city to another city in 1 second you are covering while sitting on the earth. So, my lovely Kuddu. There is nothing called rest or motion. It's all cooked up. It's all relative term. Sir, how do we remember the concept? What kind of term is it? Relative. From now onwards, if someone asks you, a boy sitting on the chair, is he on rest or motion? Say it depends on who is watching him. If you watch from the sun, then the earth is moving, hence it is in motion. But here next to Shanti, Babita is with you. King. She is beautiful and cutie. Babita is sitting next to you. Now if I ask Babita, you tell me Babita, is Shanti is in rest or motion? Babita is standing next to you. You started searching for her. No problem. Don't dream too much. Let's believe. Sorry. Now Babita is standing next to me. So I asked, is Shanti at rest or in motion? She turned and said that he is sitting. So Babita will say, you are on rest. So dear, the term rest and motion is a relative term. It depends on who is looking at you. Who is watching you? No one is watching. Have you seen your face? Let's move on. Yes. Next topic is distance and displacement. I'm scared of it. Let me tell you this easy thing. Shanti means you again came back. Walked 5 meters, then walk 5 meters, then walk 5 meters, then walk 5 meters. Where are you going? You are going there. Very bad. 5 meter, 5 meter, 5 meter, 5 meter. Where have we reached? Heaven, not heaven. Hey, bad talk. Near Babita. If I ask this Shante, how much path did he travel? How much actual path did he travel? Tell me. He went from here to here 5 meters, 10, 15, 20. How much path did he travel? He traveled 20 meters. The actual path that he traveled by walking and running, then he came here and then there. Now if I ask you about what is the shortest way to reach Babita? Sir, and a lot of money. Hey, you study physics instead of talking crap. What is the shortest way to reach Babita? Sir, by complimenting her that you look very beautiful, you are the most beautiful person. Hey, no, study physics. What is the shortest way to reach Babita? According to me, the shortest way is this, straight line. Sitak. Why walk from here to there and there to reach straight? Sitak. This is the shortest path where you can reach Babita's heart. Where you can reach Babita. Shortest path is this. Shortest. How much is this? From here to here, how much is it? 5. And how much is it? 5. So if I ask for the Shante, what is the shortest path to reach Babita? How much is it, beta? Tell me. This one is from here 5. It is also 5, right? 5. 5 and 5 means 10 meter. Finish. This is the distance and displacement. The actual path that a body or object travels is called distance. And the shortest path from the initial point to the final point is called displacement. There's the simple point. Let's go. Distance. Length of actual total path covered. Length of actual total path covered. Actual total path. Zoom, 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 zoom. What is displacement? It may happen that you didn't even take that exact route. Displacement only tells you what is the shortest path was. Whether you went it or not, that doesn't matter. Maybe that road doesn't even exist, bro. Maybe after Shanti's house, there is someone else's house. You can't just jump across and walk. It's not necessary that in the shortest path, you can always go. But the shortest possible path, if you could go straight. So what is displacement? It's a shortest path from the initial, means initial point, and final means ending point. Initial point and ending point. Shortest path from initial position to final position is called displacement. Along with the direction. Sir, what does that mean? We will understand. So are you starting to feel physics yet? What is rest or motion? Just tell me you are in rest or in motion. Sir, I'm sitting on earth and circling around. No. Again, same thing. You are lying on the bed and your dad walks in. He will say, you are lying on the bed. No, Papa, I am in motion. I am running very fast. He will say, yes, stop it. When your father will see you, you are on rest. Someone sitting on sun will see you. He'll say, yes, brother, he is in motion. So, relative term. Second, what distance, displacement, clear. Distance is what? How much total actual path, how much you walked. And what is displacement? That what is the shortest path is there. Shortest path is this one. It is called displacement. There is one thing in displacement, there is direction is also there. Direction is important. This thing I will tell you little bit later also. Let's move ahead, beta. Now here is a question. Now Shanti started from A, reached B, then reached C, turned around again, reached B. We have to tell distance and displacement. Better rock it in this question. Walk 5 meters, walk 10 meters, 10 again. What is distance, beta? How much did he actually walk? Let's add it up. First 5 meters, then 10 meters, then would have come 10 meters back. So 5 plus 10 plus 10. How much is it? 25 meters. He went this way, and then came back again. So what is the total distance he actually traveled? He walked and went here, then turned back again. Let's add it up all. How much actually did he walk? Now comes displacement. What is this? The shortest path from the initial point and the final point. So here's the initial point. And after all that walking round and round and round, you finally end up here. This is the final point. The shortest path between them is this. So how much is the displacement here? Only 5 meters. Clear? All right, tell me. Shanti walks 3 meters east and then 4 meters north. Sir, east, west, northwest. Imagine it like this. This is east, that is west, upward is north, and downward south. Simple. The right is east, left side is west, up is north. Now Shanti walks 3 meter east, 4 meter north. We asked what's the distance. Distance is the actual path. So 3 and 4, distance was very easy. 3 and 4, how much is it? 7 it is. Then we asked what's the displacement. The shortest path, the shortest route. This is the initial point and this is the final point. Which is the shortest route? Tell me the shortest route. This is the shortest route. I dashed it. This is the shortest path. That is the displacement. This is displacement. Now how do we calculate it? Have you studied Pythagoras theorem or not? If it's a right angle triangle, this side is the perpendicular, this side is the base, and this side is the hypotenuse. What is the formula? Look here, this is right angle triangle. This side we call the perpendicular, this is side base, and this side the hypotenuse. So what's the formula? H square is equal to P square plus B square. H square is equal to P square plus B square. And that's exactly what we need to find the displacement. Here only, right? Okay. So how to get it? Let's write the same formula. H square is equals to P square plus B square. Pythagoras theorem. Square of 4 plus how much is B? Square of 4 is 60. Square of 3 is 9. 16 plus 9, how much is it? 25. But if the number square is 25, then what is the number? 5. Very good. 5. So how much is the displacement, beta? 5 meters. Did you understand clearly about distance and displacement? It's clear. Let's move on to the next question. Hi, it's a bird. Now, beta, it's a bird. Just flying round and round. My dear, it's gone crazy. Round, 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 round. It's hovering. It's spinning. Now the question is, after a half revolution, from where will be the half revolution? From here, from till here you have to come. Okay. After half revolution, find distance and displacement. All right, let's first talk about distance. Distance means the actual path. What is the actual path? How much is it, beta? Sir, no idea. You studied circle, circumference. Yes, a little bit. The length of the whole circle, which we call as perimeter, the whole circumference, this whole length is 2 pi r. How much is the length of the whole circle? 2 pi r. So how much is this? Half perimeter, half circumference. So how much will be half of 2 pi r? So how much will be half of 2 pi r? It's how much is pi r. The whole thing is 2 pi r and half of it is pi r. So pi is 22 by 7. Let's consider it. And r is 14. It's given. 7 by 14 is how much? 44 meters. So the distance was very easy. Just take half of the circumference. Circumference 2 pi r. Half of that is pi r. So 22 by 7. Now comes displacement. What is displacement, beta? Think and tell me quickly. The shortest distance between initial. This is my initial. And this is my final. What will be the shortest distance between them? If I look the shortest distance, I will draw straight line joining them. This is it. This will be the displacement. Shortest distance. Tuck. Now how much it will be, beta? Sir, I don't know. Hey, it's the diameter of the circle. What is it? Diameter. Diameter means r and r. Beta, here will be the center of the circle. So how much it will be? R. And how much will be this radius? This radius. And this as well. So this will become 2 times r. R above, r below. What is the value of r? So 2 times of 14. How much is it? 28 meter. This will be its displacement. Shortest path. Now tell me one thing. Did you notice that in all questions we have done till now, this distance is coming out bigger than displacement. Notice here, distance is 44, displacement is 28. Beta, displacement is a thing which is always shorter than distance. And max to max, displacement is equal to distance. But a displacement doesn't have any status. What is it? It cannot be greater than distance. Displacement will either be less than distance or at most equal to distance. Displacement will either be less than distance. Displacement is 28, distance is 44, it is less. All right, look at the previous example. Displacement was 5, distance was 25, displacement is less. Look at this example. Distance is 7, displacement is 5, it's less. So beta, one thing you should understand here and always remember, displacement will always be less than distance. Always. There is only one case where displacement becomes equal to distance. It can never be more than distance. Displacement equal to distance only in one case, I will tell you later, when the body is moving in a straight line and continue. Okay, brother, did you understand this much? Now, what's the next question? The same bird, but this time it completed a full revolution. Find distance and displacement. Full round is completed. Full round completed. The bird completed the full circle. So beta, what is the actual path? The whole circle, which means 2 pi r. Earlier it was pi r, then it will be double of that. Now the double is 88. Pi r is double, 88. Now let's talk about displacement. Displacement is the shortest path from the initial point to the final point. Where did the bird start from? From here. This was its initial point. Going. It came back again. This itself become its final point. Oh, sir. This is the initial point. This is the final point. So the initial and final points are exactly on top of each other. Is 0. So much effort the bird queen made, and after going in a circle, she came back home. Displacement is 0, isn't it? Like they say, the same hospital in which you are born, God forbids, if in same hospital your end happens, touch wood, but it has to happen. Suppose in the same hospital where you were born, you live your life, you become a great person, earn money, bought a car, got married, had a small little kid, and in the same hospital where you were born, you passed away there. Then your displacement for the entire life is 0, because your initial and final points are the same. So displacement depends only on the initial and final points. What you did throughout the life, we don't care. Where you went, we don't care. Initial, final, that matters. Clear? So beta, displacement can be 0 even though body is moving. Once the body has started moving, its distance can never be 0. No. But displacement 0 is possible. I have written it here. An object has moved. It is written in NCERT. It's a question. Our lovely, beautiful NCERT Didi. An object has moved through a distance. It has traveled some distance. Can it have a 0 displacement? Can it have a 0 displacement? If yes, then support your answer with an example. But don't give that example about being born in the same hospital and dying in the same hospital. Don't write such a dark answer. A very simple example is a body goes from point A to point B and then comes back from point B to point A. So distance have been covered, but what will be the displacement? 0. From where it started, you came back. Second example, body moving in circle, where you have started, back there. So after one revolution, take one complete revolution. So suppose you started from A, then circled around and came back to A. So in this, what is the displacement? 0. What is next? This you got it. If initial point and final point is same, then displacement is 0. Remember this, all this example. This secret is between you and me. Please don't tell ma'am in the classroom. When can the displacement be 0? Ma'am, if you are born in the same hospital and you die in the same hospital, if we say things like that, can the magnitude of displacement be equal to the distance traveled by the object? This English gives us trouble. We know the physics, but this English doesn't come easily. Can the magnitude of displacement be equal to distance traveled by the object? This English really troubles us. Physics is simple. It's the English that troubles me. Can the value of displacement be equal to the distance traveled by the object? Can distance and displacement be equal? Of course, they can be equal. Brother, what's the problem? Suppose we start from point A and go straight to point B. Now that is our path. And that is also the shortest distance between A and B. What is the shortest path? Will you go from above? So the first point is yes, when object travels in straight line. If it's exactly straight, beta, when the object travels in a straight line, you suppose I am standing here in the front of the board and I started running and came here. That's my path. So that is my distance. And shortest path, what will become? Shortest path is also this one. So if you walk along the shortest path, then distance is same as displacement. Clear? So if you move in a straight line, your distance and displacement will be always be equal. N value. Distance is equal to displacement. I'm writing in value. Why in value, sir? Because displacement also has direction. Better, we have already discussed this. Remember? Anyway, all is well, yes. So distance and displacement can also be equal. I told you, right? What is the maximum status of displacement to become equal to distance? Mostly it is less. And when is it equal? When the object travels in straight line. No turning here or there. The moment you turn, better, game over. Then displacement will be less than distance, and displacement can at most be equal. It can never be more. Very good. You understood it all better. Now let me show you another beautiful. Very beautiful. Alright, you forget the madam. See the beauty of physics, sir. Just look for a moment. Alright, fine. Let's get madam in. An object starts from A, reaches B, then goes to C. The same question again. For the path A to B to C, for the path A to B to C, what do we need to find? Distance, very easy. From A to B, how much is it? 4. You can see 4 is there. 4. Then from B, we also came back to A. How much is that? 4, 8. And then we went to C, that is 2. So, beta, how much is the distance? We went to 4, came back 4, and then went back to. So 4, 4, 2 is 10. Anyone has any confusion? No, right? Simple. From here to here is equal to 4 meter. Let's assume it's in meter. Okay. Then how much we came back? 4 meter. Then moved a little back, but how much? 1 means 2. 2, that's 2 meter. So 4, 4, 2 is equal to 10. Now tell me, what is displacement? What is displacement, beta? It is the shortest path between initial and final. Now tell me, what is the initial and what is the final? We went from A, reached B, and finally to C. So the initial point will be A, and the final point is C. Everyone knows how much the displacement should be from A to C. How much is that? From A to C, shortest path, initial to final. How much? 2 meters. Got it, all of you? Give yourself a round of applause for this answer, because this answer is wrong. आपने हमको जो भी पढ़ाया वो तो कहीं भी नजर न आया. अरे, why it's wrong? Why it's wrong? I tell you, beta. Actually, I really don't teach you. Beta, displacement comes with direction. I told you this while ago. Beta, always when we measure the displacement, we measure it with origin. This is origin, 0. If you believe on this side of origin, then it's positive, and this side is negative. And displacement, direction matters. If we had gone this way, the displacement would be positive. But if we go behind the origin, displacement is negative. So here the answer will not be 2. No, sir, not 2. What it will be? Minus 2 meter. Yes, that concept I just explained. My mistake here. Yes. It's my mistake. If you go behind the origin, displacement is negative. If you go forward, then it's positive. Now your brain must be thinking, then let's do the same in distance also, sir, that would be fine. Distance can never be negative. Never. Never. Distance has no direction. Just keep adding, keep adding, keep adding, always keep adding. Never subtract. Never in distance. No. In displacement, you must check. If you go forward from the origin, then positive. If you go backward, then negative. If you go upward, then positive. If you go downward, then negative. So what will be the displacement? Minus 2 meter. Sir, what is this? Why study displacement at all? I'll tell you. I'll tell you everything, each and everything. How to get Babita. Oh, sorry, not that. That you have to figure out on your own. Back to topic. Suppose, beta, I say I am standing 5 meter away from you. I am 5 meter from you. Shanti, are you reading? I am standing 5 meter close to you. Now what are you doing? You looked on the right, not there. You looked on the left, not there. Looked on front, not there. Looked behind, not there. Looking up as if I am stuck in form of Spider-Man. I'm not. Where am I? Down, in the room below. The one you are studying right now. The sound will come. Yes. I mean to say, when I tell the distance that I am 5 meter away, you don't know the direction of where I am. You start looking everywhere, here, there, here, there. Where are you, sir? I can't find you. But when I say, I am 5 meter towards your right, you clearly understood my position. I said, I am 5 meters below you. You said, okay, underground, all great. Clear, beta? That's why we study displacement. Because displacement tells us how much far and in which way. It tells us direction. Which way? Now, generally, we'll say it's not there in your syllabus, but I'm just telling you once. Do you know how displacement is written? 4 meter north. It's written like this. 5 meters south. It's written like this. With direction south, north, or plus 5 meter, minus 5 meter. This is how it is represented along with direction in your syllabus. This thing is low-key in questions also, not come from it. But you should learn. Let's study the difference between distance and displacement. You will understand it like butter. Brother, distance, length of actual total path covered. Actually, how much did he walk? That is distance. Please remember it. Actual. Displacement, shortest path from initial position to final position. The shortest path has only magnitude. Distance only has value. It doesn't have any direction there. No direction. We never speak of direction and distance. We only give value, 5 meter, 10 meter, 20 meter, whatever it is. Let's talk about this. Displacement has magnitude, that is value, and direction. 5 meter north, right? 10 meter south, like this. 5 meter north, or it can also be written as plus 2 meter, minus 2 meter. There can be many ways to give direction. Not in detail, we just have to remember that in displacement, direction is also there and value is also there. Next thing, dear, what kind of quantity is distance? Scalar. Beta, scalar quantity means the ones that has value. Simple. And the one direction is not there. No direction, only value. There are exceptions too. Current is one exception, but for now, big one. Displacement is a vector quantity. Beta, vector quantity, simple definition is the one which has magnitude and direction. For your syllabus, this is enough. Other vector law and addition, leave it. Vector quantity that has value and direction as well. Scalar quantity will only have value. So what kind of quantity is distance? Scalar quantity. There is no direction of distance. You said you went from home to school. I asked, how much distance did you travel? You said, sir, we traveled 5 kilometers, that's it. Then I asked, how much displacement happened? Sir, 5 kilometers east. Do you understand? And what is this vector? That is, you gave 5 kilometers and also east. Look, there is value, here's value, and here's direction. Vector quantity is value and direction. Distance can never be negative. Distance can never be negative, whether you go here or there from the origin, it's always positive. It's a rule that's made, sir. Why not negative? Rule is made. Displacement can be positive, you saw that. Can be negative, you saw that. Can be zero. If you complete it, circle it 0. So displacement can be positive, negative, or 0. All three things can happen. Distance, beta, will always be positive. Can never be negative. Displacement can be positive if we go behind the negative, and if you circle back and come, then 0. Now, beta, distance depends on the path followed by the object. Which road you took, that's what distance depends on. Displacement tells me the initial point, tells me the final point. That's it. I will take the shortest path here. Displacement depends only on initial and final position, not on the path followed. Which path you took, we don't care. How you went to school, we don't care. Tell us the shortest distance. Shortest path, that's displacement. Didn't click it? It will click. Come, let's make it click. Suppose A and B are 2 points. I said we have to go from A to B. So let's go, sir. We went like this. From A to this way Zotuk, then this way Zotuk, then this way Zotuk. How much distance did we cover? 5, 10, 15, 5, 20. So in this path, how much is the distance? 20 meter. I said no. We won't go from here to there. We'll go this way, Zotuk, Zotuk. So how much did we walk? 6 meter and 8 meter, Zotuk, Zotuk. And this path, beta, how much distance did we travel? 6 and 8, how much is it? 14 meter. Now if I ask you how much is the displacement? Displacement will be the shortest path. So what is the displacement? Shortest path. You tell me the shortest route. Shortest path from A to B. Shortest path is this. How much is it? 10 meters. If you went by this path, then the displacement I would tell is still 10. If you went by this path, then the displacement I will tell you still 10. Displacement doesn't really care about how you walk. It only care about one thing. Initial point, final point. That's exactly what is written here. If you look carefully, see this one. Distance depends on the path followed by the object. Distance depends on the path, brother. Look here. This time, how far is the distance? 20. This time, how far is the distance? 6, 8, 14. But if we talk about displacement, depends only on initial and final position, not on the path followed. Only initial and final position. Path doesn't have any relevance. Clear, beta? Very good. Now you understand distance and displacement. Let's go to the next topic, which is speed and velocity. You must have known already about speed, that what is speed? Speed is how much fast you are walking. Simple. How much fast you are running. So what is speed? Distance per unit time. Distance covered per unit time. The formula of speed is distance upon time. How much kilometers did you walk in how many hours? How many meters did you walk in how much seconds? So what's the formula to remember the speed? Distance upon time. What is its standard unit, beta? Meter per second. Take distance in meters, time in seconds. What is another unit? Kilometer per hour. Distance in kilometer, time in hours. Now what is velocity? Now look, we studied distance and displacement. What is speed? Distance upon time. Distance upon time. What is velocity? Displacement per unit time. Simple. What is velocity? Displacement per unit time. Very simple, beta. So when they ask for speed, what will you put? Distance upon time. And when they ask velocity, what will you put? Displacement upon time. Sir, both are same thing. How is it same thing? Distance and displacement is not same thing. Oh, velocity tells something else. Distance and displacement are not the same thing. So velocity is displacement upon time. The unit is same. Displacement is also in meters or kilometer, time in seconds. So what is SI units? Meter per second. There is another unit, kilometer per hour. Okay. Now, beta, sometimes they give in kilometers per hour, but we have to convert to meter per second because the standard unit is meter per second. Why you are solving numericals? Always solve in meter per second unless they specifically ask in kilometer per hour. So, beta, in kilometer we have 5 by 18 meter per second. We have to convert it. 54 kilometer per hour. We were told to convert it into meter per second. Convert to meter per second. Very simple. Whatever is given in kilometer per hour, it's 5 by 18. With 5 by 18 multiplied. You don't remember the 18's table? No problem. 18 into 354. 3 into 5, 15. 15 meter per second. 72 kilometer per hour. How do we want it? Meter per second. So 72 into 5 by 18. 18 into 4 is equal to 72. So 4 into 5. How much is it? 20 meter per second. Clear? Now this at 36 kilometer per hour. What do we do, beta? Multiply it with 5 by 18. 18 to the 36, 2 5s are 10. 10 meter per second. So just multiply by 5 by 18 kilometer per hour will become meter per second. If asked the opposite, Then convert 18 by 5, just the opposite of this. Suppose they tell you to convert meter per second into kilometer per hour, then multiply by 18 by 5. That type is not usually asked. Generally, we have to come into this. Why? Because question need to be solved in meter per second. It's standard unit. So speed is distance upon time. Velocity is displacement upon time. Let's do two questions and understand whether these two things are different or the same. You understood distance and displacement, right? Distance, actual path. Displacement, shortest path. Let's understand more deeply what is the difference between speed and velocity. Let's take the first case. Suppose this is a car. The car's on a roll. The car goes from O to A. Do you travel in car? Sir, I have one brother. There's a senior of ours in 12th class. He comes by car to school. Yes, I once sat in his car. He drives very fast. Okay, so we went from O to A. I told brother, tell me the speed and velocity. How much distance is covered? How much was the path? 10. How much was the time? 2. Speed is very simple, beta. Distance upon time. So we went from O to A. How much distance was covered? 10 meter. How much was the time taken? 2 seconds. So how much is it? 5 meter per second. Now let's see the velocity. What is velocity, beta? Displacement upon time. Displacement upon time. We went from O to A. What is the shortest path? This itself, sir. This is the shortest path. So how much is the displacement? 10 meter. How much was time? 2 seconds. So how much is the velocity? 5 meter per second, sir. Both things are coming out same. That's because distance and displacement are the same. Why did they become same? When will distance and displacement become the same? When you move in a straight line. And here you are moving in a straight line. So they are equal value-wise. Values equal. So speed and velocity came out the same. 5 meter per second, 5 meter per second. No problem. Second case. Here is the origin O. And from origin O, where did I go this time? I went backward. See, forward from origin, backward from origin. I know forward and backward is actually relative, but for our syllabus, let's assume this side to the right is positive and this side is negative. Now we went from O to B, 6 meter. Time taken, 2 seconds. But what is speed? Distance upon time. Now tell me, does distance care which direction you went? Just tell me the value. Distance doesn't care about value. Distance and all this doesn't come in direction. What is the value? How much is the time? 2 seconds. 6 meter upon 2 seconds. How much is it, beta? 2 3s are 6. So 3 meter per second. This is speed. Now if we talk about velocity, something is coming in my mind. I understood everything. Displacement upon time. Now tell me, if I take this side as positive, won't I have to take other side as negative? And displacement involves direction. So how much is the displacement here? Minus 6 meter. Brother, it's very simple. Look at this graph. If this direction is positive from the origin, then this direction become negative. This is origin. If you look that side as positive, then this is negative. And displacement is affected by positive and negative. So minus 6 meter upon 2 seconds, 2 into 6. What is the velocity, my brother? Minus 3 meter per second. Oi, hoi, 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 hoi. So here's the story. Speed can never be negative. Velocity can be positive, can be negative, can be zero. Why? Because displacement is above. And this Mr. Displacement can be positive, negative, zero, everything. So if this is negative, then this will be also negative. Now better notice one thing. The speed and velocity values are coming out the same. Here 5, here also 5, here 3, here also 3. So velocity is basically speed to some extent with direction. With direction. Speed with direction is velocity. Let me tell you something. Suppose this is the origin. This is not greetings, it is origin. I say a car is moving at 10 meter per second. Tell me in which direction is it going? 10 meter per second. Its speed is 10 meter per second. A car has speed of 10 meter per second. Tell me where is it going? This way or that way? You can't tell me. Because speed does not talk about direction. Speed is positive here also, there also. This car speed is 3 meter per second. Which way is it going? We don't know, brother. Because speed will always come in positive. Why? Because distance is always positive. So speed has the same problem as displacement. Direction cannot be determined. Now I say, a car, velocity, minus 5 meter per second. Which way is it going? A car's velocity is plus 3 meter per second. Got it? So what do we get from velocity, beta? Direction. If we stick direction to speed, it will become velocity. See, brother, how much is speed? 3. And what is the direction? Negative, minus 3. So when speed is combined with direction, what does it become? Velocity. This is exactly NCERT writes. Speed with direction is velocity. Got it, sir. Understood physics, sir. Enjoyed it, sir. Speed with direction is velocity. Clear? Okay, now it's going to be fun. Now, brother, speed is understood. What is it? Distance upon time. And what is velocity? Distance upon time. Speed has no direction. Velocity has direction. Speed is always positive. Velocity can be positive, negative or 0. Now I say find speed. Here becomes Babita again. Babita is back. Babita is going to school. How much did she walk? In 1 second, 5 meter. In next 1 second, 10 meter. In next 1 second, 20 meter, because she is getting late. 20 meter per second is not practically possible, but okay, it's physics, it's a question. So Babita is going to school by walking. Oh no, I am late. She started running. And 1 second, 10 meter. She thought that the gate of the school will be closed, and once the gate of the school is closed, Babita can get away easily. Girls can get away, but boys can't. No beating. We can beat in school, right? And our days it was too much. So Babita was walking towards school. How much did she walk in 1 second? 5 meter. In 1 second, 5 meter. We have to keep running. She thought it will be late. She started running 10 meter. Still getting late. How much in the last second? 20 meter. I asked, tell me Babita's speed. Oh, sir. Babita's speed seems to be changing. Because in the first second, she covered 5 meter. In the next second, 10 meter. In the next second, 20 meter. If I want to calculate her speed, then speed's formula is distance upon time. Yes, sir. Distance upon time. Beta, what is the distance here? 5. What is the time? 1. So here, how much is her speed? 5 meter per second. So distance is 5 meter and time is 1 second. Let's calculate the speed here. Distance upon time. Let's calculate the speed here. Distance upon time. How much distance is covered? 10. From here till here. And how much time was taken? 1 second. So how much is the speed? 10 upon 1, 10 meter per second. Here her speed is too good, brother. How much is the distance? 20. How much is the time? 1 second, 20 meter per second. So Babita's speed is continuously changing. Speed is changing. In such cases, when speed is continuously changing, now suppose Babita reached school. Teacher said, Babita, you were running fast. Yeah, chal, I was running very fast. I was getting very late and Chanti was waiting for me. She also likes you. She is just silent. Okay. That's why she keeps turning back to look at you. Why do you think she always borrows your copy? Don't get carried away by such talk. This is how friends tease you. It's just that your work is good and you're the free helper. That's why. Yes, don't get carried away by your friends. Anyway, teacher said, Babita, were you running? Yes, ma'am, I was running and coming. Babita, at what speed were you running? Ma'am, 5, 10, 20. In such a cases, when speed is continuously changing, a new concept was invented, average speed. So we can just find the average. Average, tell us, Babita, why you were saying first meter per second, 4 meter per second. From 10 I started. So average speed came into existence here, and the formula of average speed is total distance upon total time. Total distance upon total time. And when average speed came into existence, so did average velocity also. You can tell its formula yourself. Total displacement upon total time. When do we calculate this? When speed etc. are changing. Then we talk about average speed and average velocity. That's it. Average speed, total distance upon total time. Average velocity, what was the formula of velocity? Displacement upon time. What do we do in average? Just put the total, simple. What was the formula of speed? Distance upon time. What will we do in average? Total the upper, lower the one, simple. Speed, distance upon time. Average, total distance upon total time. Velocity, displacement upon time. Average velocity, total displacement upon total time. Very good. Come on, let's ask a question. Here's a don't equation. We'll have to do it. We'll have to do it. Yes, this is a car, beta. The car starts from O point. It goes to A. Started from O. Reached A, 2 meter. Started from A. Went till B, 8 meter. From B to C, 4 meters. From C, it goes back to B. So what is the path of the car, beta? From O, it went to A. From A to B. From B to C. And from C back to B. From O it went to A, from A to B, from B to C, and then from C back to B. It asked me average speed and average velocity. You have to find. Can you do it? Very easy question. What is the average speed? Total distance upon total time. Total distance upon total time. So how much is the total distance? 2 meter, 8 meter, 4 meter. But distance is always positive. 2 moves to actual path. 2, 8, 10, 4, 14, 4, 18. How much is it? 2 plus 8 plus 4 plus 4. Total time at bottom. 1 second, 1 second, 1 second, and returning also 1 second. How much is it? 4 seconds. So how much is this? 2, 8, 10, 14, 4. 18 upon 4. 9 upon 2. Means 4.5 meter per second. Where is the distance here? N meter. Now average velocity. What is velocity? Displacement upon time. What is the average velocity? Total displacement upon total time. Now tell me what is the total displacement? Total displacement. My initial point was O. Anyone has any confusion in that? No, sir. Clear, sir. Final point is B. What is displacement? The shortest path between initial and final. This is initial, this is final. What is the shortest path? This. So how much is the displacement? 2 plus 8. Is it clear? Shortest path from initial to final. So here is the initial and here is the final. 2, 8, 10. Now beta, what will be the total time? We'll take 1 plus 1. Well, beat you. Total, we must consider entire time. From here to here, it took 1 second. From here to here, it took 1 second. And from here to here, it took 1 second. Total 1 plus 1 plus 1 plus 1, 4. So 10 upon 4. This is the mistake you are about to make. Don't make it. Why not, sir? Because it isn't there. Total. Tell me the total time it took in the entire journey. In the entire journey. How much is it? 2.5 meter per second. This is the average velocity and this is average speed. Maybe I will write the average velocity as plus because it has the positive direction. I wrote plus, not minus. Clear now? Good. Let's move to the next question. Now there's a Shanti beta. Shanti. Start from point A, goes to point B, and from B it returns to A again. The distance between A and B is 4 meter. Going took 2 seconds, returning took 6 seconds. You need to find average speed and average velocity. We have to find. Very easy. Average speed beta, total distance upon total time. What is the distance? 4 meter is going, 4 meter is coming back, 4 plus 4. What is the time? 2 seconds and 6 seconds. 2 plus 6, 4, 4, 8, 2, 6, 8, 1. What's on top? Meter. What's at the bottom? Second. Distance on top and time below. 1 meter per second is the average speed. Now tell me average velocity. Total displacement upon total time. Now tell me how much displacement went from A to B, came back from B to A. So initial is here and final is also here. Oh dear, we reached the same place, back in the same hospital where we are born. So how much is the displacement? 0. You can give whatever time you want. 2680. Average velocity 0. Even though body is moving, Still average velocity is 0. Oh dear, this is the concept of velocity. Speed can never be 0 if the body is moving. Average speed can never be 0 if the body is moving. But average velocity can be 0. If you return to the same place you started from, then displacement will be 0. Got it? If you started from somewhere and reach back to the same point, total displacement is 0. So average velocity is 0. Average speed can never be 0. Why? Because how can the distance be 0? Plus, 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 it keeps adding up. Clear? Keep putting all this in your head, you will see the difference ahead. Now look brother, a good question, Alakh sir concept, ask. What is it? Shwanti beta, you are Shwanti. You start from point A, ran at 40 meter per second, you ran towards this side 40 meter per second. How did you run? 40 meter per second. You kept running until you reach the point B. At point B, you turn back. You ran back at what speed? You ran back at speed of 60 meter per second. So you went 40. So you went at 40 and you returned at 60. We ran at a speed of 40 meter per second. And speed while returning was 60 meter per second. Now we asked to find average speed and average velocity. Look, the first one is very easy. Let's do that first. Average velocity, I think everyone understood very well. Average velocity total displacement upon total time. Now tell me, from A you started, gone to B, came back to B to A. Yes sir, the initial position is the same as the final position. Then what is displacement? 0. Take how much ever time you want, it doesn't matter how much time you take. So how much is it? 0. So average velocity is 0 because you return back to the starting point. Average velocity is 0. Now let's talk about average speed. So what is the formula of average speed? Total distance upon total time. See this amazing thing, sir. See this amazing thing. What is amazing? Distance is not given. Arey, what a bad question this is. Distance is not given. Now what to do? And time is also not given. Now what to do? No time, no distance are mentioned. Only thing told was the speed while going was 40 meter per second. Speed while coming back 60 meter per second. So beta, average of 40 and 60 is? What will be the average of 40 and 60? 50 meter per second. You couldn't think of this. Don't even think, because I am here to teach you physics. Who told you that average is taken like this? Who told you the formula of average velocity is when add both speed and divide it? Sir, it's written in the book V plus U divided by 2. Oh beta, if you study physics like this, who's teaching you like this? E plus U divided by 2. It's not like this, beta. Oh yes, very cleverly we have studied this. Madam taught this, sir taught this. V plus U divide by 2, 40 plus 60, 100 divided by 2, 50. Answer, that looks like the correct average. This is not the formula of average velocity. That's not even the formula of average speed. The formula for average speed is total distance upon total time. Don't use your own brain. Yes, V plus U divide by 2. That's written, but something else is written along with it. You only here, I like you. Not the rest as a friend. Hard only important part, B plus U divided by 2. After that also so many things written here. It is valid only under special cases when acceleration is uniform. I will explain it later. When it is applicable, B plus U divided by 2 has to be put when acceleration is uniform. So the formula of average speed is total distance upon total time. This is the 150 is not the answer. Then what to do, sir? Distance is not given. Time is not given. So let's assume the distance. Who told you not to assume? In your mind, she is already yours. Assume the distance as well. Sir, how much should we assume? Assume distance is 100. Assume as X. Or take 100. Assume whatever you want. The answer will be the same. I am a bit clever. I will assume 120. Why? Because I know that in 120 calculation will be easier. You assume X, you assume B, you assume 100, 200, 1000, you assume Babita, assume whatever you want. I will assume 120 or maybe 240 or 480 because I want to cancel and simplify. I will keep it easy. I'll keep it very simple. I'll say let distance or let A to be, if you want you can catch 100 meter. Best is 120 or 240. Both of these, take the LCM of these two, it will be the easiest one. I haven't studied that one. Try multiplying both of them, 4 into 6, 24. Look into it. I mean, by any number that you can easily cancel, take it as 100. You leave it. You take it 100. Tension. I'm scared. Take the feel of physics better. Later on, you will see why I took 120 for simple cancellation. Never mind. Assume 100, assume X, assume D, assume whatever you want. Let A to B is equals to, consider it at X. The result will be the same. Now, let me show you. We now move from A to B. Move from A to B. What's the distance? Let's assume it as 120. Let's assume whatever we want when they haven't given anything. Why should we assume 100? It's our wish. From A to B, how much is the distance? 120 meter. Now tell me how much time it will take, beta. All right, come here as well. From B to A, I believe that B to A will be the same. From A to B and from B to A, 120. So how much is the distance from B to A also? 120 meter. While going the speed is 60 meter per second, while returning the speed is 40 meter per second. So how much time did it take while going? Look, bhai, you assume the distance as 120, returning is 120, total distance 240. You assume the distance. You assumed it as 120. While returning it's 120. How much is it? 240. Calculate the time. So I said while going the distance is 120. What is speed? 60. Is it 60 or is it 40? It's 40. Let's fix this properly. How much is the speed? 40. Yo, huh. And while returning, what is the speed? 60. Now tell me how much time it will take. Very simple. What's the formula of speed? Distance upon time. Then what is the formula of time? Distance upon speed. Right or not, bhai? Speed is distance upon time. Time is distance upon speed. What is the distance? 120. What the speed? 40. 0 cancels with 0. How much is it? 3 seconds. Now come here. Apply the formula of time. Distance upon speed. While returning. How much is distance? 120. How much is speed? 60. How much is it? 260. Now you have both things. Take the formula of average speed. Average speed is total distance upon total time. Total distance, how much is it? 120 is gone, 120 is returned, 240. How much time it took? How much time it took, beta? When going it's 3 seconds, while returning it's 2 seconds. So 3 plus 2 equals to 5. So 240 divided by 5. 5 4s are 20 and 40 divided by 5, 8. So 48 meter per second. The answer is not 50. It's 48 meter per second. Now only one problem remains, sir. Why did they assume distance as 120? Because why 120 can be divided by 40, 120 as well as 60. That's why I took it. If you took 240, even 240 can be divided by 60 and also by 40. I picked the number that would cancel easily. Understood? If you take X, you will still get the same answer. So what a great question this was. Neither distance was given, nor time was given. Only speed was given. From here 40, from there 60. And they asked for the average. What will student do? Calculate 40, 60, average 50, which is wrong because average speed formula is total distance upon total time. While going 120, returning 120. While going speed is 40, while returning speed 60. While going time, distance upon speed, 3 seconds. Returning time, distance upon speed, 2 seconds. Average speed, total distance upon total time, 120, 120 to 40. 3 seconds, 2 seconds, 5 and 48 meter per second. Clear, bhai? Enjoy it better. Did you understand properly? Very good. Now let's study the difference between speed and velocity. I have already taught you all this, nothing new in it. What is speed? Distance covered per unit time. What is velocity? Displacement per unit time. Speed has only magnitude, no direction. Speed only gives magnitude, not direction, because distance is there, distance upon time. Velocity has both magnitude and direction. 5 meter per second north, 5 meter per second south, 5 meter per second west. Like when we asked Babita, direction will also needed. We ran at 2 meter per second. In which direction? At 2 meter per second, we ran forward. We ran to the right. We ran to the left. This is velocity. So, beta, what kind of quality is this speed? Scalar, because it only has value, only magnitude. And what kind of quantity is velocity? Vector, because it has both magnitude and direction. Speed can never be negative because beta in the formula of speed, distance is the numerator and distance is never negative. Time beta is never negative either. So speed can never be negative. Velocity can be positive, negative or zero. Why? Because in the formula of velocity, what is the numerator? Displacement. And displacement itself can be positive, negative or zero. So velocity can be positive, negative or zero. Clear? Clear? Okay. The next topic is very beautiful, acceleration. Now, what is acceleration? Let's see an example. A new term has come, acceleration. What is acceleration? Suppose there is a car that is moving at 10 meters per second. Zoom. And you are sitting in the back. Shanti. Bhaiya is driving in front. Our uncle Sam is driving the car. Bhaiya, drive faster, drive faster. He pressed his foot on what? Where did he put his foot? On the accelerator. And this is acceleration. Bhaiya, drive faster. Bhaiya, this is not fun. Seeing the car, swing it like a ride. All these tricks you will do. These dirty tricks. If your crush comes to know about this, then your respect is gone. Bhaiya, so your Bhaiya's uncle's son pressed his foot on the accelerator. And the speed increased. Become 30 meters per second. This increase in speed, what we call acceleration. Now, formula of acceleration will also be made. What is the definition of acceleration? Rate of change of velocity. That is change in velocity per unit time. Very simple. What is acceleration? How much velocity has changed per unit time. Very simple. What does acceleration tell us, beta? Its symbol is A for acceleration. How much velocity has changed per unit time. How much velocity is changed from 10 to 30 means 20 per unit time. So let's write the formula. So acceleration formula will be acceleration. This tells us how much fast the velocity is changing. Acceleration equal to final velocity minus initial velocity divided by time taken. The time in which the velocity changed. The time in which velocity, remember which time? Don't take any random time. The time in which velocity has changed. In how much time did it change? 2 seconds. Let's take that. What is the final velocity? 30 meter per second. What is the initial velocity? 10 meter per second. And what is the time below? 2 seconds. 30 minus 10 beta, how much is it? Acceleration. 30 minus 10, how much is it? 20. What is written? Meter per second. What is the time below beta? 2 seconds. 2 times 10 equal to 20. So 10 meter per second square. Say it's 2 seconds, right? 2 seconds meter per second square. This is its unit. Did you understand? What did I do? The formula of acceleration, final velocity minus initial velocity divided by time taken. Final 30, initial 10, time below 2. 30 minus 10, 20. And what is this? Meter per second. What is the time? 2 seconds. 2 into 10, 20. 10 meter per, it's 2 seconds. Second square. So beta, its unit, its SI unit of acceleration, how much is it? Meter per second square. It looks a bit strange. You had heard meter and you also heard meter per second. This is new. You had meter per second square. Its formula is very simple beta. The formula of acceleration is very simple. Look again, very simple formula. A is equal to V minus U by T. Now what is V minus U by T? What is A beta? A is obviously, sir, it's acceleration. What is A beta? Acceleration. It is acceleration. What is V beta? Final velocity. What is U? Initial velocity. What is T? Time taken. Final velocity minus initial velocity upon time taken. B minus U by T. And beta, we have to remember it's a SI unit. And which unit will the answer come? It will come in meter per second squared. Acceleration tells us how much fast the speed is changing. If I say my acceleration is 2 meter per second squared, and I say someone's acceleration is 10 meter per second squared, it means his velocity will increase faster than me. How much fast the velocity increases, that is acceleration. The greater the acceleration, the faster the velocity will increase. It can also decrease anyways. Come on, let's do a question. We will learn while doing questions. For now, acceleration is understood. We will remember the formula B minus U upon T. A train starting from a railway station. So, beta, there is a train. Have you ever sat in train? A train starting from railway station. That means, beta, in the beginning, the train is at rest. It is standing at the station. Now, let's go. It attains a speed of 72 km per hour in 1 minute. How does the train move, beta? It moves a straight path. So here there is no problem of direction. How much speed did it attain, beta? 72 km per hour. In how much time? 1 minute. So how much time did it take? 1 minute. Now what is asked from us? Calculate acceleration in SI unit. Let's apply the formula of acceleration. A is equal to V minus U divided by T. What is V, beta? Final velocity. Now tell me, what is the final velocity? 72. But what is this? Kilometer per hour. We need acceleration in which unit? SI per unit, meaning meter per second. So first let's change kilometer per hour. So beta, 5 into 18, 5 into 18, 18 fours are 72, 4 into 5, 20, so 20 meter per second. This is the final velocity of the train, so this becomes V. What will be the initial velocity? If something is standing still at rest, what will be the velocity? 0. But if something is not moving at all, then its velocity is 0. If I am standing, what is my velocity? What will be my speed? 0. So whenever it is said a train starting from rest or a ball dropped from rest, ball dropped, whenever this word is used, ball dropped, whenever it is used, dropped. Dropped means released from rest. The initial velocity is 0. A train starting from a railway station from rest, so what is it? 0. Now beta, let's put it in the formula. V is 20 minus U, which is 0. Time taken 1 minute. Now beta, in denominator we must keep time in second. So in 1 minute, how many seconds? 60 seconds. So this cancels to 1 divided by 3. And what will be the unit? Meter per second squared. 1 divided by 3, beta. What will be the answer? 1 divided by 3 is 0.33. It will be, see. So it will be 0.33 meter per second squared. Clear? Now look ahead, beta. In the formula of acceleration, notice this on the top is velocity. And velocity has direction. That is why acceleration also has direction. Look at the formula of acceleration. Acceleration is equal to V, final velocity, minus U, initial velocity, divided by time. Acceleration formula, look carefully what is written. Change in velocity. That's what is written. How much velocity changed upon time. It has the change. How much the velocity changed. In the formula of acceleration, velocity is on the top. Velocity, beta, brings direction. That's why acceleration also has direction. Acceleration is also a vector quantity. What is it? A vector quantity. And a vector quantity has magnitude and direction. It has magnitude and direction. That means acceleration, like displacement and velocity, can be positive, negative, and everything. Now it doesn't have that bhai. Like displacement, bhai was distance. Velocity, bhai was speed. But acceleration has no brother or sister. Simple, okay? A vector quantity has magnitude and direction. Now what I am going to tell you, listen carefully. I will tell you a very lovely, beautiful point. Suppose this car is moving like this. Suppose this car is moving in. Now if I press the accelerator like this and zoom, the speed will increase. And if I hit the brake, the speed will decrease. That is also change in velocity. Understand this point. Change in velocity does not mean that velocity will keep increasing, It can also decrease. Oh. So if I press the accelerator of the car, my velocity increases. And if I press the brake, the velocity decreases and it decreases further. So acceleration has two directions. The first direction is when the acceleration is the same direction as velocity. Acceleration and velocity are in same direction, in the same direction. In such a case, what will happen when acceleration is in the direction of velocity? It will push the car forward. So the car speed will keep increasing. So if acceleration is in direction of velocity, then beta, what will speed do? Say increase in speed or increase in velocity. Write it as speed increases or better velocity. And when acceleration is in the same direction as velocity, we take it as positive. How do we take it here? Positive. Velocity in this direction, acceleration is in opposite direction. That is the direction of acceleration. The car is moving forward and you are pulling it back. Yes, pulling it back. Yes. Think of acceleration in your mind as something like force. Now suppose a car is moving like this way, not a real car but the toy car. If you push it from behind, it runs forward, because where the velocity was, imagine this toy car, you push it from back, or wherever you applied acceleration, speed will increase in that direction. But suppose this toy car is moving this way and you push it from the front, or the toy car is moving and you pull it back a little, then its speed decreases. So if acceleration is in the opposite direction, if you pull it back, then beta, what will speed do? Speed decreases. Or you can also write it as velocity decreases. And when acceleration is opposite to velocity, then we take it as negative. Very simple. When velocity and direction in same direction, speed will increase. And in this case, acceleration is positive. When velocity and acceleration are in opposite direction, speed will decrease. We are stopping it. It is going. Speed will decrease and acceleration negative. That's what is written here. Acceleration is positive if it is in the direction of velocity. Acceleration is negative if it is opposite to the direction of velocity. If it is in the direction of velocity, then positive. If it is opposite, then negative. Let's move ahead, beta. A question has come. What is the question? Shanti is paddling his bicycle. Shanti is riding at 8 meters per second. So Shanti is riding at how much? At 8 meters per second. On the way, he saw Babita while riding. Oh, Babita. What will he do? He'll try to cut across. That's why it's not going to happen. Stop the bike quietly, yes. But by Shanti is like you. He applied the brake, he hit the brake. And after braking, his bicycle stops after 4 seconds. From here, after the next 4 seconds, his bicycle stopped under the 4 seconds. Stopped within 4 seconds means it came to rest. Came to rest means velocity is 0. Initially, what was his velocity? The initial velocity is u, 8 meters per second. Finally, he came to rest. What is the final velocity? 0. It stopped in seconds. What was he asked us? Find the acceleration. Come on, let's calculate. Acceleration is v minus u divided by t. What is v, beta? 0. What is u? 8. What is time? 4. How much does it come? Minus 2. And the unit of acceleration is meter per second squared. Look carefully, bhai. What I was explaining to you is exactly what has came out here. Acceleration is negative. Speed decreases until it becomes 0. That means acceleration was applied in the opposite direction to velocity. Velocity was this way and acceleration was applied in the opposite direction. See, acceleration came out negative. Arab, I didn't do anything. I just asked a question. I said, how was the Shanti moving? 8 meters per second. He applied the brake and stopped. Stop means he came to rest. So velocity becomes 0. Initial velocity was 8. Final 0 and the time taken 4. The formula of acceleration is v minus u divided by t. Final 0, initial 8 divided by 4. It comes out minus. Acceleration being negative means you are reducing velocity, stopping it. You are decreasing the speed. It keeps decreasing, 0. That means acceleration is in the opposite direction. So whenever you apply brakes, beta, note this down. Whenever in a question, beta, you see brakes. Brakes means what will be the acceleration? Negative. Brake means now we will reduce velocity. It will be negative. Come on, bhai, let's move back. Now we have to study uniform motion and non-uniform motion. This confuses a lot, sir. What is it, uniform and non-uniform? Is it the uniform that we wear in school, sir? It's very easy. I am telling you, physics is not difficult. What is difficult? English is difficult. It's very easy, bhai. What is uniform motion? Come, bhaiya. Shanti sat in car. You sat in car. And you said, I will drive the car in such a way that in the first second, I will cover 5 meters. And the second also, I will cover 5 meters. In the next second also, I will cover 5 meters. That means every 1 second, you will cover exactly 5 meters. First second, 5 meters. Next second, 5 meters. Next second, 5 meters. Can I say that in equal time intervals, you are covering equal distance, and equal time, you are covering equal distance. Can I say that? That is what we call uniform motion. When a body covers equal distance and equal intervals of time. Very simple. And every 1 second, how much I am covering? 5 meters, 5 meters, 5 meters. It could also be 10, 10, 10, or it could be 20, 20, 20, anything. As long as in equal time, we cover equal distance, that is called uniform motion. All right. So one thing is clear, an equal time, equal distance is covered. Now understand the second thing. If I ask, tell me something about this car speed. So beta, let's write the formula of speed. Speed is equal to distance upon time. Now tell me, what will be the car speed in this interval? How much is the distance? 5 meters. How much is the time? 1 second. 5 meters upon 1 second. So what will be the speed here? 5 meters per second. Tell me in this interval, what will be the speed of this? Distance upon time. So in this interval, what will be the speed? 5 meters per second. And this interval also, how much distance is it? 5 meters. How much is the time? 1 second. 5 meters per second. The meaning is, when uniform motion happens, then what is the speed of the body? Same. It's same, constant, or what else do we call it, beta? Uniform. Uniform means completely flat, completely same everywhere. Understood? So constant speed or same speed remains in the uniform motion. It is written, the speed is same. So 2 points are clear about uniform motion. The first point of uniform motion is that in equal time, equal distance is covered. Second, if we talk about speed, then what should be speed remain? It should stay the same. Third thing, tell me this. Does this car have any acceleration? Is it increasing its speed? Is it decreasing its speed? No, same. That means no acceleration is happening. The car is moving with the same speed it had. So what is acceleration? 0. By final velocity is the same. Initial is also the same. In between also the same. Velocity itself has not changed. So acceleration is 0. Okay. So let's look at an example of this. A car moving with constant speed. Like this is car shown above. Clear? Now comes non-uniform motion. Now it's very easy. Just take the opposite of this. Non-uniform means it will not be uniform. So first thing, here is this car and Babita ji sat inside. Hey Babita ji, hey, set ka tire the car. Now Babita ji hasn't really learned how to drive. Shanti bhaiya taught her, he taught her. Babita ji sat somewhere. In the first second, how much did she travel? 10 meters. How much did she travel? 20 meters. Speed increased. And the next second, you move forward. How much? 30 meters. Means if we watch Babita ji, then Babita ji, an equal time, is she traveling equal distance? No. An equal time, she is covering unequal distance. This is what we call non-uniform motion. In the first second, 10 meters. In the next second, 20 meters. The next second, 30 meters. So what is she doing? In equal time, she is covering unequal distance. So unequal distance and equal intervals of time. Here in equal intervals time, equal distance here, in equal intervals of time, unequal equal distance. Clear? Now comment on the speed of Babita ji. Here what will be their speed beta? The formula of speed is distance divided by time. So here what will be the speed becomes now? 10 meter. How much is time? 1 second. So 10 meter per second. Is the speed same here? Distance upon time. How much is speed now? 20 meter per second. It increased by here. Now here tell me, distance upon time. How much it will be become? 30 meter per second. That means speed is continuously increasing. It could also decrease. So it will either increase or decrease. meaning it will change. It is written here. What will speed do? Change. And what was happening here? Same. Third thing, now tell me. This now, since speed is changing, that means acceleration is happening. You are pushing it. Speed is increasing, which means acceleration is there. So acceleration is not 0. By final velocity, something else, initial something else, and in between those are something else. That means acceleration is not 0. Let's take an example. A car moving with variable speed. Variable means it can change its speed. Variable speed. But this kind of motion is more practical. In real life, this is what happens. It is very difficult to maintain one fixed speed. That kind of motion where speed doesn't change at all is an ideal type. You are driving on the road, but you are at 5 meters per second. A horn is blaring, but you say you will do uniform motion today. Right, Babita ji turned out to be more intelligent than Shanti. Girls are actually more intelligent than boys. Comment and tell me, are girls more intelligent than boys, or boys are more intelligent? I feel girls are the more intelligent one. Because I am married, so I have to speak carefully. Let's move ahead by. Okay, so uniform and non-uniform motion is clear. Uniform motion equal time, equal distance, and non-uniform equal time, unequal distance. If we talk about uniform, then speed same, and non-uniform speed changes. And uniform, if the speed is same, then there will be no acceleration, no push, no pull applied. Non-uniform, the speed is increasing, that means acceleration will happen. Now beta, let's come to graphs. Now graph seems really scary, right sir? We don't understand those graphs question. I'll give you such a strong weapon for graphs that you will shoot down those graph questions one after another. Honestly, I'm telling the truth. You think I joke all that, and no job, this is serious. You understand a few tricks, a few hacks with me, and then by graphs, it'll be pure fun for you. Come, let's understand by what happens in a graph. In one side, there's y, on other side, there's y, there's x. This is y's value. You seen this much? Right, must have seen the graphs, right? Haven't you? Okay, y and x. Now understand one thing in a graph, what we need to carry. The first thing is slope. What? Slope. S-L-O-P-E. Slope. Now beta, what is slope in a graph? If I just explain it to you lightly, then understand it is this y divided by x. That's slope. What is it? Y divided by x. If you divide this, what do you get? Slope comes out. But actually the real formula of slope also has to be studied. The actual formula of slope is y2 minus y1 divided by x2 minus x1. What is this? Very simple. If I give me the slope from here to here between these 2 points. I pick this point, I pick this point. I said between these 2 points, what do you have to give me? Give me the slope. So we'll use the formula beta. What is the formula? y2. Now see, this is the first point and this is the second point. We need to go from here to here. y2, what is the y of this point? 30. Minus y1, what is the y of this point? 20. Divided by x2 minus x1. This point, this is the second point, right? What is its x? 6. Minus this point's x, how much is it? 4. Tell me, did you understand? Nothing to do, beta. If they ask you to find the slope between 2 points, if they ask you to find the slope between 2 points, then from the y of the second point, subtract the y for the first point. This point's y is 30 minus this point's y is 20. From the x of the second point, subtract the x of the first point. This point's x is 6, this one's 4, 6 minus 4. 30 minus 20, how much is it, beta? 10. 6 minus 4, how much is it? 2. So how much the slope will be? 5. So the slope of this graph at this place is 5. Okay, do one thing. You find the slope here from this point to this point. Write this down as homework and comment it. Comment and tell me what the slope comes out to be of these 2 points. If this is point 1 and this is point 2, then how much the slope will be? You will comment and tell me, bhai sahab. Find the slope of this point and that point and comment it. Did you understand slope? Roughly speaking, it is ratio of y and x. Ratio of y and x. If you want to calculate the exact slope, then y2 minus y1 divided by x2 minus x1. Beta, did this make sense? Now let me explain to you the slopes of 4 or 5 graphs. After this, your distance time graph. And another one, velocity time graph. Acceleration time graph is fully clear. Come, let's see. Let's go. Now, ask has come by Alakh sir concept. Even the spelling of concept is shaken up. Don't even know the spelling of concept. We'll explain the concept. Understand this slowly. Now, very important thing. I'm telling you something very important. Your friend won't tell you this before the exam. Why this is important? Study it properly. Come. If in y and x, you see a line like this, a perfectly straight line cutting through the origin. This is the origin. If a straight line is passing through the origin, then its slope will be constant. Constant means it will be remain same. The slope of this graph will not change. What kind of slope it will be? Constant slope. If we calculate the slope of any graph at 2 points, take the slope here, take the slope here, take the slope here or here, what will it will be everywhere? The same. The slope will be constant. Okay. Now look at this. Suppose this line is not straight. It's something like this. The curve can be like this or like this. Any kind of curve or like this. If the line is not straight, beta, then your slope is changing. Like in this case, it is increasing. If we reverse it, it would be decrease. If it's not a straight line passing through the origin, then your slope is changing. Here it will be increase. If anything else forms, you must understand it means changing. The slope keeps changing. The slope between these two will be something else. The slope between these two will be something else. These 2 points will be something else. As the points keep changing, the slope will keep increasing. Third case, if the straight line is parallel to the x-axis, straight line parallel to its parallel line, x-axis. If you have a straight line that is parallel to the x-axis, then in this case, how much is slope? 0. At any point you can calculate. Here it's 0, here it's 0, here it's also 0, here it's 0. The slope is 0. 3 things I have told you. These 3 will be used the most. These 3 you have to fix in your mind, bro. Without this, don't even touch graphs. Otherwise, you will just keep memorizing, keep getting confusing, keep guessing randomly. Got it by graphs finished. First thing, if the graph is a straight line passing through the origin, then what is the slope? Same. Second thing, if it's anything other than straight, like this, or it's like this, anything is there. If it's not a straight line, then what is happening to the slope? It is changing. Like in this case, the slope is increasing. Third point, if it's a straight line, but parallel to the x-axis, like this, then how much is the slope? 0. These were the only things you have to remember. The third one is very easy, beta. If the line is going downwards like this, shook. If the line is going downward like this, then what is the slope? Negative. If the line is going down like this, then the slope is negative. This will be used in one of the case. Now understand one more thing, beta. Here is a graph drawn. There is a line A and there is a line B. Now the question is, whose slope is greater? Whose slope is greater? Very simple, beta. The one with the larger angle, the one that is more tilted upwards, whose angle is like this, that line slope will be greater. For example, if I took this angle and assume it is 30 degree, then clearly this other angle is larger than that. How much it will be? Let's assume it's 60 degree. So beta, the line with the greater angle will have the greater slope. That means slope of B is greater than slope of A. Clear? Suppose I draw this graph. Tuk, 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 2, 1, 2, 3, A, B, C. Now tell me whose slope will be the greatest? Which one has the largest angle? C. Then whose B's? Then whose A's? These 5 things we will remember and our graph will be on fire. Clear? Straight line through the origin means slope is constant. If it's some kind of curve or anything else, slope changes. If it's a straight line parallel to the x-axis, then the slope is 0. Third, if the line goes downwards, then the slope is negative. Fourth, the greater the angle a line makes, the greater its slope will be. Now look, let's study the distance time graph. So beta, I have a distance time graph. On the y-axis, what do I have? Distance. And on the x-axis, what do I have? Time. This is the distance time graph of a body. 0 second, 10 second, 20 second, 30 second. 0 meter, 20 meter, 40 meter, 60 meter. The first thing we need to understand is, what is slope of this graph? If I ask you the concept of slope, the very first thing I have told you was, roughly speaking, what is it? Y divided by x. Here on the y-axis, what do I have? Distance. On the x-axis, what do I have? Time. That means I can say that the time slope of this graph is distance upon time. Oi, hoi, hoi, hoi. What is distance upon time, bhaiya? Speed. So, beta, the slope of this graph is what? Speed. The slope of this graph will tell us what? It will tell us the speed. Why? Slope, I told you, it's y over x. Y-axis is distance, x-axis is time. So, distance upon time. Remember this, the slope of distance time graph, the slope of the distance time graph, what will it tell us? It will tell us speed. Distance time graph, what will the slope tell us? Speed. You must remember this one thing, that the slope of distance time graph will tell us speed. Clear? Remember this always. The slope of distance time graphs, the slope, what will it give us? Speed. Okay. Now tell me one thing. What kind of slope does this graph have? No cheating, bhai. No cheating. Pause and comment. No cheating, bhai. What kind of slope does this graph have? Is it a constant slope? Can I say this slope is a constant? A straight line passing through the origin. If the slope is constant, and slope means speed, then beta, can I say here what kind of speed it is? Constant speed or same speed. And this graph, the speed will not change. Clear? Alright, if the speed is the same, remember that car you are driving 5 meters per second, 5 meters per second, 5 meters per second. If the speed is not changing, then what kind of motion it is? Uniform or non-uniform? If the speed is not changing, first 5 seconds 5 meter, next second 5 meter, next second 5 meter, equal distance in equal time, what kind of motion? Uniform motion. So what kind of graph is this, beta? This is the graph of uniform motion. Okay. So the first thing in distance time graph, what is slope? Y divided by x, distance divided by time, that means speed. Second thing, what kind of slope is this? A straight line passing through the origin, constant slope, which means speed will be constant. It will not change. Write constant or understand it as same. It will not change. And if speed is not changing, then what kind of motion is it? Uniform motion. Now a question comes. You have to find the speed in the interval from 20 seconds to 30 seconds. They ask us, tell us the speed here. Now, bhai, here is distance, here is time. How do we find speed? I can tell the distance at 20 seconds. What's the distance? 40 meters. At 30 seconds, what's the distance? 60 meters. But what are they asking me? They are asking for speed. So, beta, how will we find speed? We know that in this graph, what does the slope give us? Speed. So, we'll calculate this slope. What's the formula of slope? y2 minus y1 divided by x2 minus x1. Which points do we have to take? The ones at 20 seconds and 30 seconds. That means this is 1 point and this is the second point. So, y2 minus y1. The second point's y is how much? 60. Minus the first point y is how much? 40. Upon x2 minus x1. What is its x? 30. x1 is 20. So, 60 minus 40 is how much? 20. 30 minus 20 is 10. So, what do we get? 2. Now, beta, this is speed. What will be the unit? Distance is in meter, time in seconds. So, the speed will be in meter per second, 2 meters per second. Clear? Now, you do some homework. Do one thing. You calculate the speed between these 2 points. You calculate the speed. Homework. Comment and tell the speed between which interval? From 10 seconds to 20 seconds. And then check and tell me if the speed is coming out the same, because I already wrote that it's a constant speed. Straight line passing through the origin, that means slope is constant and the slope speed is constant. Now you can check and tell me. Alright, let's move ahead. Next, beta, once again I have distance time graph in front of me. Now I already know that the slope of distance time graph gives us what? Speed. This point is set in my head now. Now tell me, what kind of graph is this? What is the slope of this? Is it constant or is it changing? By for constant, it has to be straight line passing through the origin. That means here its slope is changing. So I will say, what kind of speed is this? It is a changing speed. Changing speed. To be more accurate, it is increasing. What kind of slope does this have? The slope of this graph is actually increasing. But you can also write it as changing. Changing means it's not the same. It's changing speed. If better the speed is changing, like Babita ji who was driving the car, in the first second 10 meter, in the next second 20 meter. In the next second, 30 meter. The speed is continuously changing. That means in the first second she covered 10, in the next second 20, in the next second 30. Equal time, unequal distance is being covered. So what kind of motion is this? Non-uniform motion. So if such a distance time graph comes, what will you say in the motion is non-uniform? If it looks like this, beta, or if it looks like this, look, let me show you more. It's a straight line, right? Suppose this graph comes, here's distance, here's time. What kind of motion is this? Non-uniform. By look here, it's not a straight line. Okay. Suppose this graph comes here, distance time graph, distance time graphs comes like this. Then what it will be? Non-uniform, because the speed is continuously changing. The slope is continuously changing. If it's not a straight line passing through the origin, then the slope keeps changing. So here the slope is what? Increasing. You can call it changing speed or increasing speed. Both are correct. Clear? All right, bye. Next. Now once again we have a distance time graph. Who recognize this one? Parallel to x-axis, right? Can you see it? Parallel to the x-axis. Okay, tell me, what does the slope of distance time graph give us? Speed. If the graph is parallel to the x-axis, what did I have taught you? What is slope? How much is it? 0. So here what will be the speed? 0 speed. 0 speed means what? It means I am standing still. 0 speed means I am at rest. At rest, so this graph is of what? A body at rest. A body at rest. Look, at 0 second, what is the distance? 20 meter. At 10 seconds, what is the distance? 20 meter. At 20 seconds, what is the distance? 20 meter. That means after walking 20 meters, we stopped. We came 20 meters from the origin and then we stopped. Time is passing by. At 0 second distance is 20. At 10 second distance is still 20. At 20 second distance is still 20. I'm not moving at all. The body is at rest. So a straight line parallel to the x-axis means the slope is 0. And what does the slope of distance time graph gives us? It gives us speed. So here 0 speed. 0 speed means the body is at rest. The graph is crystal clear. Very good. Bye. Now let's do a question. What is the question asking me? The question is asking me, what can you say about the motion of an object whose distance time graph is a straight line, a stiff line, parallel to the time axis? This is the time axis and the line is straight parallel to it. Tell me, what can you say about this? Beta, what is the slope of this graph? 0, parallel to the time axis. And what does the slope of distance time graphs tell me? Slope of distance time graphs tell me, it tells me speed. So what is the speed here? 0. No speed. No speed at all. So what about the body? The body is at rest. The body is at rest. Clear? This is beta your distance time graph. These questions can come. Sometime it asks speed, sometime uniform, sometimes non-uniform. That's it, done. Now one question, you comment and tell me how much did you understand. Comment on this question. Here we have A, here we have B. Tell me which one is uniform and which one is non-uniform. Distance, time. So I am making two graphs. Tell me which one is uniform and which one is non-uniform. Tell me which is uniform and which is non-uniform. All right. Next beta, explain different regions of the graph. This is a distance time graph. You have to explain different regions of it. Very easy beta. Distance time graph. We know the slope of a distance time graph. What will it give us? We must remember what it will give beta. Speed, distance upon time. What does that become? Speed. That's what slope is, right? Y upon x. Distance upon time, speed. Okay. Now in this region, what kind of slope is there? Constant. So constant slope means beta, what about speed here? Speed is constant, because the slope is constant. Okay, constant speed means speed is not changing, moving with the same speed. What kind of motion is this? Uniform motion. Okay, come to this region. Parallel to the x-axis. How much is the slope? 0. And what does slope tells us? Speed. So what does this become? 0 speed. 0 speed means the body is at rest. All right. Now come to this region. What is the slope here? Not constant. Whatever it is changing. It is increasing. So here the slope is changing, which means speed will also change. So here we can say speed is changing. Actually it is increasing, but you just remember it changing. If such a graph is there, better than I should understand the slope is changing. Suppose it was drawn like this, then to what would the slope be doing? Changing. Okay. And a distance time graph, if a such graph is drawn, this is wrong. I'll explain it later. So yes, speed is changing. If speed is changing, then what kind of motion is it? Non-uniform. First second 10 meter, next second 20 meter, next second 30 meter. Clear now? Beyond this beta, nothing more can be ever asked. Everything is covered. Let's move forward. Alright. Next is the velocity time graph. Now what does the slope of velocity time graphs gives us? Let's understand a little. What does the slope of velocity time graphs gives us? Beta, what is slope? You all have understood by now. It is y divided by x, roughly speaking. Otherwise, of course, you will use y2 minus y1. Roughly, y divided by x, y upon x. If I look at y divided by x for this graph, this is the velocity time graph of what? Velocity with respect to time. Right, at 0 second, how much is velocity? 0. At 10 second, how much is velocity? Sorry, at 0 second, what is the velocity? 0. At 10 second, what is the velocity? 20 meter per second. At 20 second, what is the velocity? 40 meter per second. At 30 second velocity, how much is it? 60. Now, what will the slope of this graph gives us? Y by x, which means in a way we can say it looks like velocity upon time. Right? Roughly. This formula is correct to understand. Just to understand, velocity upon time. But wait, velocity upon time, nothing is coming to mind. I do remember something to final velocity minus initial velocity divided by time. V minus u divided by t. Ringing a bell, does it sound familiar? V minus u divided by t. That means on top is velocity, final minus initial, and below is time. And what is this thing? Acceleration. So beta, what does this slope of graph gives us? It gives us acceleration. Remember this. Slope of distance time graph is speed. Slope of velocity time graph is acceleration. What does the slope of velocity time graph give? Acceleration. After that, everything becomes easy. But now tell me, what kind of slope is this? It's a straight line passing through the origin. So the slope is constant. So beta, what kind of slope does this graph have? Constant slope. Fixed slope. Same also. So we will say what kind of acceleration is here? Constant acceleration. Now beta, constant or same, we also call it uniform. Oh sir, yes sir, don't know this now. Wrong thing sir. You called the uniform, now don't call this one the same. Yes, this is not the uniform motion. Absolutely not. What? Why not? Because the speed is continuously changing. At first the speed is 0. At 10 seconds the speed becomes 20. At 20 seconds the speed becomes 40. This is absolutely not uniform motion. But the acceleration, that is the same, right? And the same means uniform. So it's uniform acceleration, not uniform motion. No, don't get confused. The motion is definitely not uniform, but the acceleration is uniform. So we call that uniform acceleration. And the acceleration is constant. Is this motion uniform? No, it cannot be. Why? You see, at 10 seconds the velocity is 20 meter per second. At 20 seconds the velocity is 40 meter per second. At 30 seconds the velocity is 60 meter. Motion is not uniform. But yes, what about the acceleration? It is constant. Okay, good. So can I write what kind of motion is this? Non-uniform motion. All right, clear? Non-uniform motion, because speed is changing. Or you can just note like this, uniform acceleration. Remember this, the motion is non-uniform. Uniform acceleration. Uniform acceleration. Meaning the acceleration itself is constant. Sir, is that different? Yes, it is different thing. Uniform motion is separate thing. Okay, now find the acceleration in the interval from 10 second to 20 second. So the question is asking us the acceleration from 10 second up to 20 second, from here to here. Now by how do we find acceleration from velocity time graph? Obviously acceleration will be the slope of this graph. And what is the formula of slope? y2 minus y1 divided by x2 minus x1. Now which 2 points are we talking about? By what did we say? From 10 second to 20 second. So from here to here. For 10 second, this is a point on the graph. For 20 seconds, this is the point on the graph. So this becomes our first point. This becomes the second point. All right, now let's apply the formula by y2. The y of the second point, how much is it? 40. minus y1, the y of the first point, how much is it? 20, divided by x2, the x of the second point, how much is it? 20, minus x1, how much is it? 10. So 40 minus 20, how much is that? 20, and 20 minus 10, that is 10. So 20 divided 10, how much is it, beta? The answer is 2. And beta, what will be the unit? Meter per second squared, because this is the unit of acceleration. Tell me, did you understand this? Now you do one thing, write it down as homework and tell me in the comments, what is the acceleration 20 second to 30 second, what it is coming, check it. Is it coming out the same? Because it should, since the acceleration here is constant. So check it once and see. Yes, bye. Now the second velocity time graph. Now we already know that the slope of velocity time graphs gives us acceleration. Now tell me, in this graph, how's the slope? Is it changing or is it constant? Changing or constant? It's clearly visible, its slope is changing. So here the acceleration becomes changing acceleration. Now beta, changing means the value of acceleration itself is non-uniform. I am not making any comment about the motion here. Acceleration's old value of what it is, non-uniform acceleration. That's why I will teach it later. But since NCERT writes about it, I have to mention it. This is nothing to do about motion. It's simply that value of acceleration here keeps changing continuously. You check it. You check it yourself. You do one thing. Find the acceleration in the interval from 10 second to 20 second and find the acceleration in the interval from 20 second to 30 second. You will see how the value comes out. It will change. The value of A will change here. You calculate it and check yourself. You can do that, right? Take the first point, second point, then this point, then that point. All right, bye. Let's move ahead. Next is velocity time graph parallel to the x-axis. Now beta, if parallel to x-axis, then what is the slope? 0. 0 slope. And what does the slope of velocity time graphs gives us? Acceleration. So here we can say that acceleration is 0 acceleration. Now beta, what does 0 acceleration mean? Think about it. Or you can even see it. 0 acceleration means speed will not change anyhow. No push happening. Acceleration means a push or pull. Acceleration means either you are pushing or pulling. But yes, neither is happening. Acceleration is 0. So with whatever speed you are moving, you will just keep moving at the speed. Now look here carefully. At 0 second, what's the speed? 20 meter per second. At 10 second, what's the speed? 20 meter per second. At 20 second again, what's the speed? 20 meter per second. So beta, what is the speed here, beta? The same. And if the speed is the same, then what kind of motion is this? Uniform motion. I am talking about motion now. This is uniform motion. Clear? Okay, let's do a few more questions and the concept will be clear. Look at another one. This is velocity time graph. So, I told you earlier, right? If the line's graphs going downwards, then what's the slope? Negative. Yes, sir, negative slope. I already told you. If the graph line goes downward like this, then what will we take the slope as? Negative. And what does the slope of velocity time graphs gives us? Acceleration. So here, what kind of acceleration is it? Negative acceleration. Better remember what happens in negative acceleration. Remember I told you, if velocity is in this direction and acceleration is applied in the opposite direction, then in that case we say acceleration is negative. And what happens to the speed? Tell me, think. Negative acceleration means the body wants to move that way, but acceleration means we push or pull. Acceleration has the same relation as force. So it's simple. The body is going forward, but acceleration is pulling it back. So what will happen? Its speed will keep decreasing. What will speed do? Decrease. So, question. What can you say about the motion of an object if its speed time graph is a straight line parallel to the time axis? If its speed time graph is a straight line, this is speed time, right? Now here velocity and speed we are considering almost the same. We actually shouldn't, but in our syllabus we will take them as the same. Velocity time graph, a straight line parallel to the time axis. Time axis parallel, this is straight line. But a straight line parallel to time axis, then what will its slope be? What will the slope be? 0. Right, let's write speed here. No problem. So what's the slope? 0. The slope is 0. Okay. For your syllabus, we are assuming speed and velocity to be the same. Velocity time graph. What does the slope gives us? What does this graph slopes gives us? Velocity time graph slope, what will give us? It gives acceleration. So here, what is the acceleration? 0. Here, acceleration is 0, meaning there is no push happening, no pull happening. Then what will happen to speed? It will remain the same. Speed is the same, then what kind of motion is it? Speed exactly the same, 5 meter per second, 5 meter per second, 5 meter per second, uniform motion. Alright. Now there's one thing you need to watch. Velocity time graph. They ask you to find distance. If they ask you to find acceleration from velocity time graph, that's very simple slope. It's very simple, y2 minus y1 upon x2 minus x1. But if from a velocity time graph, they ask you to find distance, then you don't have to do anything. The area under the velocity time graph is equal to distance. This is a velocity time graph. Area under means whatever area lies beneath this graph below it, along with this time axis, that area, sir, how will you calculate the area? What does area mean? Area under velocity time graph. Whatever area is inside here, you calculate it like this triangle that will form. Look at this. This shaped portion, this area, this shaded. This area, when you calculate it, what will it give you? It will give you distance. So many times they will give you a velocity time graph and ask you distance. How will you calculate it? The shaded area under the velocity time graph. Okay. And if they ask displacement, then it becomes tricky. Then the area above is added and the area below is subtracted. Many times an area is also formed below. So if displacement is asked, then add the upper area and subtract the lower area. But in your syllabus, what do they usually ask? Generally, they ask for distance. Come, let's do a question. This will get clear too. Let's say we have a graph here. It's a velocity time graph. What all we ask? First of all, calculate acceleration in the first 2 seconds. In the first 2 seconds, acceleration is being asked. Let's do first part. What is acceleration in this graph? It's the slope. What will slope be? y2 minus y1 upon x2 minus x1. Now first 2 seconds. So this becomes the first point and 2 seconds. This becomes second point, 1 and 2. Alright. So what is y? For the second point, y is 4. For the first point, y is 0. For the second point, x is 2. For the first point, x is 0. So 4 upon 2, how much is that? 2. And the unit of acceleration, meter per second squared. Now look at the second part, what it is asking. Acceleration in the last 2 seconds. That means the last 2 seconds from 6 seconds to 8 seconds, from 6 to 8. These are the last 2 seconds of this graph. See here, 0 to 4, 5, 6, 7, 8. So the last 2 seconds. That means one point of your graph will be here of graph and the other point of your graph will be here of graph. Right. This you will take as a dotted line. Now let's come back. So one point is here and one point is here. Okay. This now this is point 1 and this is point 2. So what will be the acceleration here, beta? Again, it will be slope y2 minus y1 upon x2 minus x1. Better the graph ends up here. This is not line continue further. There is no line beyond this. There is no line over here. Okay. This dotted line is only drawn for reference. So y2 minus y1 upon x2 minus x1. For the second point, how much is y? It is negative 4. For the first point, how much is y? It is 0. For the second point, how much is x? 8. For the first point, how much is x? 6. So negative 4 divided by 8. Sorry, 8 minus 6 equals to 2. Negative 4 divided by 2. How much is it? Negative 2 meter per second squared. So what kind of acceleration is this? Negative. Look at the slope itself is negative. The velocity time graph, the slope is going downward. So the acceleration is negative and that's why the answer also comes out negative. Clear, bhai? Next, what is being asked? Distance covered in 6 seconds. From here till here, they are asking for distance. Okay. Distance covered in 6 seconds. Now, beta, from the velocity time graph, how will we find distance? I just taught you this. To find distance, what you should calculate? The area under velocity time graph. Now from where to where do we need to find the distance? From 0 to 6 seconds. So here is the graph. The area under this graph, this entire area, we need to calculate this. This entire area we need to calculate. Now by how do we calculate this area? There are two triangles and one rectangle. How much is it? What is the formula of area of triangle? You know the triangle of area, half into base into height. So half into base is how much? 2. Height is how much? 4. Then what is this? This is rectangle. Everyone knows the area of rectangle, right? Length into breadth. So how much is this? 2. And how much is this? 4. This distance is 2 only, right? From 2 to 4. This side is 4. Then by what comes next? Triangle. Triangle area half into base into how much is it? 4. 6. How much is height? 4. So this 2 cancels out. How much remains? 4. 4 into 2, 8. 2 cancels out. How much is it? 4. 4, 4, 8, 8. 16 meter. So how much distance was covered? 16 meter. Now the last part, beta, the time period of uniform motion. Now it's asking me, where is the motion uniform? Uniform motion means what? Uniform means acceleration should be 0. Speed should be same, which means the slope should be 0. Didn't understand? Uniform motion, beta. What it want to say, beta? Same speed. Same speed means the final velocity should be the same as the initial velocity. And if the final velocity, initial velocity are same, then how much will be acceleration? Be 0. So how much should be the slope? Be 0. Now where is the slope of this graph? This part is constant, this part is negative, this is 0. So this area is of uniform motion. That means from 2 second to 4 second is the motion uniform. Clear? Let's move ahead. Now we have to study the equations of motion. Whether there are actually many formulas of motion, many equations, but we only have to study those equations when an object travels in a straight line. That's it. We only have to study that. We don't have to study anything else, like it moves in a circle, then what equations will form, right? Not too deep, forget that. Straight line. Just if an object is moving in straight line, completely straight like this. It's like this also, it can also like this, it can also like this. If it's moving straight, then some equation will form of motion. One more condition. With uniform acceleration, not uniform motion, but acceleration uniform, meaning you can say when acceleration is constant, then all these equations will be valid. And don't worry, in the exam it will be written as yes, by the acceleration is constant. What are the equations? These are the 3 equations of motion, beta, when acceleration is constant. The first, v is equals to u plus a t. Second, v square minus u square is equals to 2as. The third, s is equals to ut plus half at square. So Shanti, beta, first write this down, copy it, note it down and memorize it. First learn it. V is equals to u plus at. V square minus u square is equals to 2as. S is equals to ut plus half at square. First learn them and then comment, ma'am, I memorized it. What kind of things are you saying? Look at the nonsense you people say. I'm calling you ma'am. Learn them and then comment. Sir, I have memorized it. Only after you memorize it, then only we will move ahead. Sir, I memorized it. V is equals to u plus at. V square minus u square is equals to 2as. S is equals to ut plus half at square. Now let me tell you what things are telling what, beta. Beta, everyone knows what is u? Initial velocity. What is v? Final velocity. S tells beta how much distance have been traveled, and t tells us how much time it took. Clear? Actually, S tells us displacement, but in your syllabus we just write distance and carry on. This is the kind of lie that tell in the 9th class, life's biggest lie. Just pass 9th grade and life will be fun. Just pass the board exam, life will be full of fun. Just clear 12th exam, life will be full of fun. Just crack IIT and life will be full of fun. Just get a job and life will be full of fun. Let's get married and life will be full of fun. Just have a child and life will be full of fun. And the child goes to school, life will be full of fun. But the child gets married, life will be full of fun. You reach the grave and life will be full of fun. Beta, there is no automatic fun in life, right? So u is initial velocity, v is final velocity, s is distance and t is time taken. Okay? Okay. Clear? Good. Now let's do question based on these formula. A bus starting from rest. I already taught you this. Whenever it is written that something starts from rest, it means the initial velocity is 0. Whenever you start from rest, the velocity at the beginning is 0. So u is 0. Moves with a uniform acceleration. They already written it themselves. That means you can apply the formula. Uniform acceleration is given. So go ahead and try the formula. Moves with a uniform acceleration of 0.1 meter per second square. So beta, in this question, I already know the initial velocity starts from 0. Then I know its acceleration. It's 0.1 meter per second square. And they've given the time of 2 minutes. So I've got the time also. How much is it? 2 minutes. But we don't have to write in minute. We have to write in second. 2 multiplied by 60 second. Got it? Now question says find the speed acquired. It's asking how much speed will be gained. Okay, so what's the question, beta? There's a bus. Here, the same bus in which Babita travels. How did it start? From rest. So u is equals to 0. Then what happened, beta? It accelerated. Accelerated means some push was applied on the bus. Boom. Oh, now what will happen? Its speed will increase, right? Increase or not? Its speed increased. So that's final velocity. What was asked? Find the speed acquired. Meaning they're asking the final velocity. They are asking me the value of v. Now beta, how will I calculate it? Which equation should I apply? Very simple. Just took u is known, a is known, t is known. So the first equation will work. B is equals to u plus a t. Now how much is u? 0. How much is a? 0.1. How much is time? 2 multiplied by 60. So beta, when you remove the decimal at 10, 10 will come. Your head will fly off. 2 multiplied by 6, 12. 12 meter per second. Clear? Next has been asked, distance traveled. When this bus increased its speed, how much distance did it travel from here to here? Distance we are now denoting with what? With s we denote it. So they have asked me for s as well. They have asked me for s too. Now which formula should we apply? Whichever you like, apply it. It will work with the second formula also. I am applying the second formula. Both will work right now. B square minus u square is equals to 2as. Let's apply this. What is v? They have already calculated. V is 12. So 12 square minus u, how much it is? 0. It's square. 2 multiplied by a, how much is it? 0.1. And s we have to find. That's what we need to calculate. 0 squared is 0. Don't calculate 12 squared. Just write 12 by 12 is equals to 2 multiplied by 0.1 multiplied by s. Now beta, all of you will go that side. All of this move where? Or should we do that here? Yes. So 2 ones are 2. 2 6 are 12. Here from s value what it is? 12 into 6 into 10. How much is it? 12 6 are 72. So 720. This is the calculation. Your brain is blasting about. Is it clear? 720 meter. You can also calculate using third formula. S is equal to ut plus half at square. Look, you know u, you know t, you know a, you know t. Work finished. Let's move ahead. Next question. Now what is it? That brakes applied to a car. Now brakes have been applied to a car. Beta, applying brake means you must be wanting to reduce speed. I had also told you earlier what happens in a braking case. Brakes are applied to produce an acceleration of 6 meter per second squared and the opposite direction to the motion. They themselves written it. So the car, beta, must be going this way. This way. Opposite direction means where is the acceleration applied? Backward. Backward means what do we take acceleration as? Negative. I have already given you so many hints in this question. If you studied carefully with me, you will understand everything. Brake means what kind of acceleration? Negative. Applied to a car to produce acceleration in the opposite direction. That itself means this acceleration is negative, backward. So the very first thing is that acceleration, instead of 6, you will write minus 6 meter per second squared. This is the mistake students do. Don't take the acceleration as positive 6 in this question. Brake is applied. Brake means the car is being pulled back. It wants to stop. Acceleration is opposite to motion, opposite to speed, which means it is negative. Okay. If the car takes 2 seconds to stop, obviously after applying brakes, the car has to stop. Otherwise, there will be accident. So what happened after a little while? 230 there. Hey bhai, copyright strike comes from the singing song. Assume the car eventually stopped. If the car takes 2 seconds to stop, then how much time car took to stop? 2 seconds. Which means beta, it came to rest. Came to rest means what is the final velocity? 0. Its final velocity is 0. Now they asked to calculate distance and travel during this time. So basically S is asked. What is S? Now beta, we know A, we know T, we know V, but how do we calculate S? Arey tata. Tell me the formula of S. None of the formula seems to be working. The first one was V square minus U square is equals to 2AS. This won't work here. The second formula is S is equals to UT plus half AT square. Now tell me you will able to find this. By U is not known. So from this one we can't solve it. From that one you can solve it. Again, U is not also known. So whichever formula of S you pick, U is sitting inside it. For S, by there are only two formula, V square minus U square is equal to 2S, and S is equals to UT plus half AT square. And in both, U is sitting here. We'll first have to curl up the calculate U, sir. It will take some effort in this question. It will happen in 2 steps. Understand that. In 2 steps. Come on, let's first calculate U. We already know VTA. So let's apply the first equation, first one. V is equals to U plus A into T. Now what is V? 0. What do I need to find U? What is A beta? -6. And what is the time? 2. So this becomes 0 is equals to U minus 12, which means U comes out to be 12. And what should the unit be? Meter per second, because it's speed. Now better you can find S using any formula, either the second one or the third one. Means the second or third I will use. B square minus U square is equals to 2AS. So how much is V? 0. 0 square minus is how much? 12 squared equals to 2 into A, which is -6 into S, and we need to calculate. So this becomes minus 12 into 12 is equals to 2 into -6 into S. Negative on both sides cancels out. 2 multiplied by 6 equal 12. 1 12 cancels other 12. So what is the value of S? 12 meters. How much distance will it cover? 12 meters. Clear? Blow your minds, check it out. You can calculate this using this formula. Both formula will work the same. You just make sure that U was calculated correctly or not. That's all you need to check. If U is correct, then S will be also correct. Let's verify using the other formula. S is equals to UT. U is equals to 12. Time is 2. Half AT square. Half A, how much is it? -6. And then T squared is 2 squared. So 12 into 2, 24. And there is a minus come. 2 into 4 minus 12. So how much is it coming? 12. Correct. Perfect. Let's move on. One more question. I'll do just 3 questions more. A stone is thrown vertically upward direction. We threw a stone upward with the velocity of 20 meter per second. So we have a stone and we threw it up into the sky. Who says there is no hole in the sky? Just toss a stone and see. Still no hole will appear. Yes. So when we threw stone upward with a velocity of 20 meter per second, so when we threw it up, then I showed velocity was 20 meter per second. Now it says the acceleration of the stone during the motion is 10 meter per second squared in the downward direction. Beta, just think. When we throw something upward, does its speed increase or decrease? Your heart might say it's increasing, but look carefully, decreasing. Haven't you played catch some catch with a ball? You take the ball, run and throw it like that. You didn't, haven't you? And as the ball goes higher, it goes down, slows down, and it will stop for a moment and then starts coming down. That means with the while going up, the speed is decreasing. Okay. Why did it decrease? Because gravity axis is downward. That's exactly what is going to happen. So that is the thing. If the acceleration of the stone during its motion is 10 meter per second squared in the downward direction, acceleration is downward. Now tell me what is the acceleration will be? Minus negative. So wherever the motion is happening, the acceleration is opposite. So negative. So think, so the ball is being pulled, it's like some force is stop. And finding the ball stops. All right. What will be the maximum height that will be attained by the stone and how much time it will take to reach there? Now tell me what height it will attain, because it throw its stone upward and goes. Question is how high it will go. Where will it stop? Beta, what will happen is this. The acceleration is opposite to the direction of motion in case by stone reducing its speed, reducing until at one point speed becomes, it will come to rest. When it threw a ball upward and that is stop at the top? No sir, it comes down. Of course it comes down. So beta, what happens is we threw the ball upward and gravity pulls it downward. So the speed keeps decreasing until it becomes to rest. That means its final velocity is 0. The question answers two things. First, what will be the maximum height attained? So we have to study the formula for height. The height here is the same as distance traveled upward. Second, how much time it will take to reach that height? Let's find that first. We know U, we know A, we know B, and the time being asked. So let's apply the first equation. V is equals U plus AT. Final velocity V is 0, initial velocity U is 20, and acceleration is minus 10, and T is unknown. Rearranging, we get 10 equals to 20. Cancel from both sides. T comes to be 2 seconds. That means after 2 seconds, it will stop. The next thing being asked is height. Height here is simply means that distance traveled upwards. The distance from here to here is that what becomes the height. You can call it H or S. It's the same thing. So we need to calculate distance. So height, or you can call it S also. So how do we calculate S? Let's use the second equation. B square minus U square is equals to 2AS. How does V? 0. So H minus 0. Initial velocity is 20. So 40 AS minus 10, and distance is S. So this becomes 0 minus 20 to 20 equals to 2 into minus 10 into S, that is minus 400, which means minus 20S. Negative cancels on both sides. So 20 meters. That has goes and it falls down. I've shown you just 3 questions here. You should practice more yourself. I'll make another video with more problems too. Now let's move beta. Now let's come to uniform circular motion. Now we have come to circular motion. In circular motion, they have written one term, uniform. What do they call it, uniform? They say that we will move in a circle. The first point you need to understand is this, that they are saying that we will go around in a circle and we will perform circular motion. What does that mean? Suddenly it feels like a ghost. What will it do? We will move in a circular motion. But how? With the same speed. We will not change the speed. The speed will remain constant. Yes, the speed will stay constant. We are not supposed to change the speed. That means you can say the speed is what? Uniform speed. The value of speed will not change. That's what is called uniform circular motion, in which the speed is uniform. The value of speed will not change. The speed's value change nahi hogi. All right, understood? I won't write it more. You already got it. Yes, sir. Anyway, doesn't matter. Now the second point here is the very important one. Suppose there is a circular motion. Some object is moving in a circle. Anything that going round and round and round and speed. With the same speed. At this point, the speed is 10 meters per second. Okay. At this point, it's 10 meters per second. It keeps going round and round here to its 10 meters per second. Again, here also speed is 10 meters per second. That means the speed of the object is the same everywhere. It is the same. The speed is the same everywhere. Look anywhere. Here the speed is 10 meters per second. Now tell me, will its velocity also be the same everywhere? Tell me, will the velocity be the same everywhere? Will the velocity be the same everywhere? It will also seem the velocity is same. Okay. Now give yourself slap. No, really slap yourself. No, I can't come out and slap you. So you do my job and give yourself a really good slap. Hence not to hurt, otherwise you will say, physics wala told student to slap himself. Student knocked unconscious. Nothing like that, beta. Velocity will not the same. Are you a fool? Really, a complete fool. Velocity God's direction and we've forgotten. Speed is constant, but velocity is not, my beta, because the direction keeps changing. Look here, what is the direction of velocity? Like this, suck. What is the direction of velocity? Zook, like this. At this point, here the velocity is going this place, zook. And this is velocity, zook. And now by this, at this point, I take 4 points. Let us take 4 points. 1, 2, 3, and 4. Now if I take these 4 points, now look carefully. Now I got the 1 point. Where is the velocity going? This way. At this point 2, it's going upwards. At the point 3, where it is going? In this side. At point 4, the velocity is going downward. Here is the velocity is downward. Did you get it? I got it. No, I didn't. I got it. Didn't need it, didn't get, didn't, got it. Now look at the circle. I got the circle. Now imagine this circle. You have circle going round. And if this point goes this side, and this point will go this side, and this point will go this side. That means at this point, the velocity direction of the body is what? Is this way. And at this point, the velocity direction is upward. Here is the velocity direction is this. Here is the velocity direction is that side. That means that the velocity direction is changed 4 times. Not just 4 times, my beta, countless times. At every point is different, right? Now look carefully. I'll ask you one thing. At this position, the velocity direction is like this. At this point, moving around the circle, the velocity is like this, moving in a circle. It will go this side. The velocity direction is turning continuously. The direction just need infinite times. It changes every single moment, every single second. Now look here, velocity is this way, meaning direction wants to go like this. So to move in a circle, you keep changing your direction every second, again and again. But the magnitude of your velocity remains the same. Since velocity is a vector quantity, magnitude plus direction. The magnitude is constant, but the direction keeps changing. Yes, sir, understood. The one who earlier said velocity is the same everywhere must have slapped himself by now, I feel. So you can write it like this inside it. See this, understand completely with these. Velocity is made of 2 things, right? What do we take better? Do people take 2 leaves and sugar? Velocity is made of 2 things. One is the value of velocity, which you call magnitude. And the second is the direction of velocity. Now if I ask here, what is the magnitude or the value? That is the same. Uniform circular motion, that means speed has to be kept the same. So what is this? Same. But what is happening to the direction, beta? Change. So overall velocity, what will it do, beta? Change. Overall velocity, what will it do? Change. So beta, this is such an example where speed is the same, but velocity changes in the exam question came. Can you give me an example? Where? Give me an example of motion where speed remains the same, but velocity is changing. So this is circular motion, uniform circular motion. If you write only circular, uniform circular. Uniform means speed is the same everywhere, but velocity is changing because direction is changing. Clear? Tell me, is there an acceleration or not? Sir, but final velocity and initial velocity are the same, so there will be no acceleration. You will study in 11th, right? Then you will learn this. There will be acceleration. So here you also write this point. 2 points are done. Third point is acceleration is non-zero. Okay? Sir, but from initial and final array that we will study in 11th also, acceleration is not 0, beta. Is not 0. How it is calculated, that I cannot tell you right now. Okay? You will get scared. But acceleration is not 0. Understand one more thing, beta. The radius of circle is r, velocity is v. If I want to know the relation between v and r, it's very simple, beta. Speed is equals to distance upon time. So what is the distance of the whole circle? 2 pi r. And suppose it is covered in a time t. Like this I can write it. Okay. Suppose I say I need to find this v. So beta, what is the formula of speed? Distance upon time. That's it. Now tell me, what is the speed here? V. In one complete motion, how much distance is covered from here and coming back to here? 2 pi r. And suppose it took time t to do this. So relation v is equals to pi r divided by t. Write it here. Suppose radius is r, velocity is v. So v is equals to, and one complete round from here to here, what is the distance? 2 pi r, and suppose the time taken is t. Clear? So now give example of uniform circular motion. So you can say any satellite that is revolving around the earth with constant speed. A satellite revolving around earth in a circular orbit with constant speed. Okay? It revolves in a circular orbit and moves at constant speed. Okay? In a circular orbit, it's actually difficult around earth. They generally don't revolve in a perfect circle, but still we wrote it. A satellite revolving around the earth in a circular orbit with constant speed. Second, a cyclist on a circular track at constant speed. Speed has to be kept the same continuously, but velocity will change because direction is changing. There is one more concept. Suppose in our hand we have adha. Adha means stone. Yes. Not the bad kind of adha. Yes. And a thread tied to it. And holding it, we are spinning zoom, 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 zoom. If I had something, I could show this. But there is nothing here. I found something. Okay, I'll show you this. I'll show you with this. Okay, let's hold this. Now suppose I, yeah, better. Now suppose I'm spinning it like this, like this. Now what's going to happen when I leave it? I'm asking when I leave it, I'll throw this way. It's a headphone. If I spin it like this, see like this, like this, like this. Yeah. If I leave it, will it go in circle and everybody will know what will happen. Everyone knows what will happen. It will go. The point is, why did it fly away? Why didn't it keep moving in circle? We spin it in circle. Then why did it run away? But it's very simple. I already told you this in a little while ago, that when you're spinning it like this, at that moment its velocity in this direction. At this moment its velocity is that direction. At this moment its velocity in this direction. At this moment its velocity this direction. So the instant you release it, the moment you let go, whichever direction its velocity is in that direction it will fly. Suppose I release it here at this spot. There. Turn. It will go forward. Should I do it? Okay, ready? Steady. Now listen guys, I'm taking a big risk on you. Just for you guys. If it breaks, I have to pay for this. Please. Okay, bye. If I spin it in a circle, if I release it here, then it will go there. If I release it here, then it will go in front. And if I release in front, we have to fly on this way. So that will go. That's it. See, whichever direction its velocity is pointing, that's the direction it will go. Here its velocity is forward direction. Here its velocity in this side. Here it's this side, right? So let's say I release it here, then see, at this part. If I release it here, then it will go like this. Here its velocity in this direction. Let's see what happens around. It's gone. And now, so remember this. Whichever direction velocity is, that's the direction. Okay. So beta, here's your chapter ends. Download the notes, study there. Keep studying. Good, all the very best.